Alright, I don't usually do a lot of videos where I talk because it's not my job to teach you how to do this. I mean, you're more than welcome to look at the work and deduce how to do something yourself. But I'm going to go ahead and I'm going to do a Frankenstein from start to finish, and I'm going to try to explain, I mean, what I'm doing, why I'm doing it, and why I do things how I do them, not necessarily what you see on the internet. I mean, it's real close to that, but there's a better way to do things than just blindly following the sheep. Okay? So, there will be some pauses. I only got my phone. I'm not an influencer. I do real work. I don't really have time to do videos. I get more work done when I just do the work. But, you know, I understand also people want to know what type of service they're getting. We're going to start with a base Frankie package here, which is we're going to do a 40 nanometer swap. We're going to harvest from a working slim. We're going to do the Sony voltage config, hardware level, replace the NECs, and we'll do the Syscon training data, and we'll also undervolt the cell in the RSX, and we'll go from there. This video may pause, start, stop, resume, because once again, this is on my phone. So right now, let's get to it. So first thing we're going to do is we need to put our board on the jig. Now, 15 years ago when I was doing this, I had custom aluminum jigs. Some years ago, I threw them all away and never thought I would need them again, and turns out this is back in play now. So we do sell these jigs for about $200. You can find them on the eBay. You ain't gonna find much. I mean, this is what you'll find, except for the Chinese special. These are designed for my Jovies. That gets us exactly the height that the board needs to be from the bottom preheater. So for your rework machine, you may need to figure something else out, or raise it or lower it. It's all dependent on how your machine works. I always put my 4 middle screws in loosely here, because I did my best. It's pretty well aligned, but always leave some play when you're doing this, is my suggestion. So I put those ones in first, and we'll start moving around the perimeter next. Just so you guys know, I mean, I used to own a very successful repair shop out in Wheat Ridge. I was reballing before most of you people even knew what the term reball means. The PS3, to me, I know this like the back of my hand, and it's nothing like, I mean, the size of it is big. The BGA grid, everything about it is big. I work on real, I mean, I'm not saying this isn't a real thing, but I mean, I do real nowadays work. I mean, we're talking SMD 01005, grain of salt type work on iPhones and Samsungs for data recovery, CPU swaps, UFS, stuff like that, you know. you know, not to toot my horn or anything, but, you know, we're working on things that size, okay? That's about the size of that whole RSX, okay? So, when I say the PS3 to me is nothing, it's exactly what I mean. This when I found out this was back in play, I was like, wow, I can fire up my 6K worth of rework machines that have been sitting collecting dust, because we don't use rework machines on electronics for today, except for GPUs. I get a lot of GPUs from mining and AI that are neglected or ran over hot, you know, and sometimes they need a chip replacement or something like that. But irregardless of the size of the electronic you're working on, you know, if the profiles ain't right, the temperatures ain't right, I mean, you can pull pads, I mean, anything can happen. So this comes down to level of experience in all reality, and anyone that's doing this type of work, I'll run rings around them. I was doing reballs on these, of course, with, you know, the regular 90 nanometer. I attempted putting 40 nanometers on these boards. I've tried everything. Some genius cracked that code, and that's great, but it doesn't change the fact that I was doing this while most other people were in diapers. Okay, I'm old school. All right, so we need to get this board ready. So need 4 of those. And we're gonna put Capcom on top of the RSX shield. You ask why? Well, on the 90 nanometer removal, it really doesn't matter, but it does help create a more even IR. I use IR. I don't use hot air. Hot air, I use it when I'm doing, you know, my hot air, you know, my hot air one, but other than that, my rework machines are all IR. It's what I've always used. It's what I know. We're going to clean up the area a little bit. I use some MEK. Okay, MEK is my main cleaner. The real stuff, not some diluted stuff. That's real lab grade. And we're just going to clean up the area a little bit so we can get a good stick on things. And then I usually use, especially when I'm doing BGAs, I do MEK, acetone, and then 99.9 IPA is the last final clean. But just to get our tape to adhere well, because we're going to be running flux through this, we're going to just make sure everything's nice and clean, so the tape adheres well, if that makes sense. Okay. I'll just let that air dry, and I'm going to be back. I'm going to go get a micro thermocoupler that goes actually underneath the chip. Unlike most people that just throw something over here or wherever they put it, I go actually underneath the chip into the ball grid array. So let me go grab that while the IPA is drying up, and we'll get the board prepped and ready to get on the rework machine. Alright, so once again, from 20 years of experience, these are what I buy. These come from Omega. Okay, they're very expensive, like 5 of them is $300. These are lab grade micro bead thermocouplers, fast reaction. I mean fast. So that's what the deal is here. Okay, so first thing we're gonna get the foil around is gonna be the first thing we're gonna do, or we can go ahead and put this on the Capcom on top of the RSX. And you ask, again, I said it helps spread the I-arm a little more evenly, but especially on removing the RSX. What it does is protect the surface, mostly, is why I do it. But I just have habit, and once you build a profile, you never change anything about it. It's always the same, or one variable can throw off the whole rework process, and then you're sitting there stupefied why things aren't working, overheating, not breaking loose, things of that nature. So once you find a profile that works, you stick to it, and part of that profile is this on top of the RSX. But like I say, main thing, when you pull that off that slim and go to reball it and clean it and work on it, you can have it upside down. I don't remove the IHSs like these hot air guys. I don't need to. It actually removes a lot faster and cleaner with the IHS on, because it really creates an even heat field. So that's just to be known. But hot air has a problem with that, apparently, or that's just how other people do things. That's not how I do things. So I always leave the IHSs on. And I try to get this on without a bunch of wrinkles in it. So get it set. Come down the middle. Smooth it out. Okay, hook scalpel, trim around the blade or around the IHS. Make sure don't hit the board, because you'll cut it up real good with a scalpel, surgical grade scalpel. One thing about, since we're kind of just doing things here, we could talk a little bit about this. This jig is 6061 aluminum, 3/8 inch thick. No flex, no warp. That's it. Okay? It'll forever be that. It ain't like that Chinese steel plate shit that, excuse my French there, that you know, warps when you're using it, heats up and starts warping. Let's see here, I need to find my, okay, perfect. Okay, so now you know, I do the foil just because it's habit, and once again the profile was built around it, but I can literally clean this BGA site without protecting anything around it here. So I mean, to each their own. Everybody makes a mistake, so sometimes you're good. Plus it cuts back on flux running around the board all over the place, you know what I mean? So use this little brush here that we sell on our eBay too. This is a hard scrape here and a soft brush here that's pretty stiff. This is for cleaning underfill and stuff off of cell phone chips and things like that, but it also has a bunch of other purposes or uses, whatever works, right? So that's how we roll. I already ran this board. We did this syscon on it. I could just show you real quick. So it was coming up with 4401 3034, okay? And basically, unless if someone had like reworked this or caused some problem, whatever, 4401 is a bit training thing with the cell not reaching the RSX, so we're gonna deduce that it's the RSX. It's always the RSX, right? That's mine. I get people that, oh, I need this fixed or that fixed. I'm like, I don't do that. We replace the RSX no matter what. So that's the end of the story. We don't just do tokens. We don't just fix a Blu-ray drive. I mean, if you're local, sure, we can fix your Blu-ray drive, but mailing stuff around and spending $100 on shipping and stuff, it's not worth it unless you're going to get a high-level repair. And that's the thing. Other people may do these Frankies and do them how they do them. Okay? Me, I do them one way. Premium. We only do premium. Okay? I may take a week to do one. I could probably do one in a day if I really felt like it. But I take my time, and I whatever, we're going to go through the process. We're going to try to get this one done. It is Saturday morning. Try to get this done by Sunday night. We'll see. I'm sure we can get it done before then. Okay, so I put my micro coupler under the RSX. Underneath it. Not on the side. Not over there. Whatever. And the profile for removing this chip is a little more top heavy because we don't care about the chip. We care about the board the most. So we're going to put a lot less stress on the board, if that makes sense. And that's where we're at. Okay. Now we're going to put, this is called Superior number 99. I put it in little bottles like this. I buy this by the gallon for like $500. Okay. This is the difference between an amateur or a DIY or something like this. I've been doing this a long time. This is exactly what is needed to do what we need to do. Okay, I'm not saying other fluxes don't work, but I've already went through the list, and that's what this is. This is designed not to burn off until around 210. It'll start smoking. It starts bubbling around 160 to 180. You know, it activates around exactly where we need it to, right around 215 to 225. Okay, this is the stuff. There's no question about it. Okay, we're gonna take a quick pause here. All right, so now let's flood the chip. And I usually put I go across, I start here, 1, 2, 3, 4. Kind of let it run down through the BGA grid. This really cuts back on the oxidation all the way, so that once you get to cleaning your pads, you don't get the black pad China syndrome, is what I call it. No clue why, but if you don't have good flux and you just heat this up and remove it, you'll get dead pads that you gotta scrape away to get down to the tin because there's oxidation on them. So don't let anyone tell you, I mean, too much flux when you're attaching the balls can be a problem. That is true. But for removal, you can't, you know, there isn't like too much, except for you put too much, it'll start going all over the board, going through the holes and dripping on the rework machine and stuff like that. But I mean, that's irrelevant really. So I always like to make sure we just get this juiced up pretty good. Generally, when you start applying on one side and you can see it kind of pushing out the other side, you're good to go. I just get my old man spectacles out here and let's do an examination of our tape off, our thermal probe placement, all that good stuff. Looks pretty good. I'll pause you and we're gonna move to the rework machine. Alright, gets pretty loud out here from the fans, the exhaust, all that good stuff. I got this thing already set up for this particular rework machine, is set up for this board over and over and over. I never change it or anything about it. So we're gonna put it on there, plug in our thermocoupler, and then let's see, I got this old school laptop here. Looks like, oh, we had a power outage a little while back, so this little laptop here works good with this system. So we'll get in here and oh, trying to, man, gotta block my password, guys. Sorry, I was trying to do it, but the internet, some genius will decide to sit there with the AI and figure out what I typed in. Okay, so unlike some people with the Jovies that run them in manual, I don't do that. I've got built profiles that run the same every single time. Alright, so we're gonna remove this chip, and that's what we're gonna do. And you know what, I'm not a stingy person. If you've got a Jovi and you're not sure what's going on, that profile might help you out a little bit. Maybe, maybe not. But you'll notice my jig is designed exactly to allow placement into the stock Jovi holder as well. And that's the reason that holder is at that height, is a reason. That's the height that the bottom heat needs to be from the board to prevent popcorning and other things, if that makes sense. Okay. I have my laser set up just like that. We got that. I mean, you don't necessarily need to close this, but we can. And then, lo and behold, the spacing from top to bottom is the same as bottom to board. Under. It's exactly the same. Okay? The reflector, I'll let you figure that one out on your own. Okay. I got this cheap piece of junk here for rework. Because I like to have my shovel. Okay, and this is a cheap shovel setup and it does the job. Got a spool of low melt, 132. Okay, super expensive, but that's what we use. And then there's other things, like I tell you, I've been doing this a long time. Y'all use whatever you use. I use things actually designed for BGA. Okay, this wick here is designed for BGA. BGA, see that? This is what it is. I mean, these are extremely expensive, but I also use this as a secondary after the BGA. So we do two passes, sometimes 3. Okay. So before I get started, I like to do a couple of things here to get ready. And we actually have a little piece here left over from the last job. And here we got a little piece of the BGA too that's already cut and ready to go. These are ready to go. Because watch, I'm going to show you how it's done. As soon as I remove the chip, I'm cleaning the board. It's going to take me a couple of seconds. Okay, got our low melt right here, and we're going to need these, and I'll show you why. After we solder wick everything, I'm going to actually, while the pads are still molten, I'm gonna actually run these across the BGA site, and we're going to get the tin pads to actually divot down factory, where they're actually recessed into the board, and remove everything but the tin for the most part. So I'll show you that soon. And it looks like I'm out of water for my cleaning station here, so let's go take care of that. So what I meant by that is my sponges for my dill here. Let's see, we need funnel. There we go. Chemical closet. Okay, yeah, we need the sponges for the soldering iron need some water, so we'll get it filled up here real quick and go from there. This is the same type of water you would use for your ultrasonic cleaner if you needed to do ultrasonic cleaning. Okay, that's filled up. Let's go ahead and pause, and we'll get moved back over the rework machine. All right, need that to clean up our solder blade. Okay, so we've got that set. One thing we got to do, take this down, or I'll call the fire department. Yeah, I'll put it over there. Okay, so we're going to click to start, and last time I had this doing an attachment, so we need to move this temperature up to a safety limit of 240, and we'll go from there. Okay, so we're going to start there. Here's my push rod, my prod. I got this from my stepmom. She used to work for RCA back in the 70s and 80s, and I've had this all those years. I started using it in around 95. So now at this point, we're gonna let things warm up here. Here's our thermal coupler up here. Okay. So I'll go ahead and think I got enough space on here to record everything, so we'll see. And of course I'm doing this on my phone, so if a phone call comes through I get cut off and the video stops and I gotta restart it. So we'll just see how it goes, guys, but I'll stitch everything together in the end. I try to like to make everything one video, even without pauses, but because, you know, everybody's got something to say. You know, that's fake, that's this, blah, blah, blah. You know, to me, I really don't care. You can send your unit in or don't. I mean, there's a couple of people, I'm not going to say that they don't know what they're doing, but they're younger, and some of their work, I've watched it, and it's not that impressive. So, you know, cutting corners, taking off the slim boards, all the poly caps to build your tantalizers. Yeah, we don't do that. I actually, you know, I buy thousands of dollars of poly caps from DigiKey, brand new, high quality. Same with the SMDs, X5, low ESRs. You know what I'm saying? Where a lot of these other cats, they're just, you know, cutting corners, pulling all those off of like slims and stuff. Like I could easily do that if I really wanted to. I could come over here. Here's from the last couple of months of Frankensteins that I've done, and we could pull all those off there and build tantalizers with them and give you a nice used poly cap, and who knows, right? But yeah, we don't do that. Okay, so the profile takes how long it takes to get there. Generally about 10 minutes. You don't want to go up too high. You don't want to go down too high or too fast, you know, too fast, too slow. You definitely don't want to sit at peak very long either, you know. It's all these different factors. Get the suction tool ready. It's ready for picking the chip. See what's going on over here. Right now we're preheating down there the board up to about 130, and then we'll start a soak. You can see the flux in there bubbling away. At 130, there we go. And see, that's the thing with that micro thermocoupler. You see it bouncing around like a couple of digits here and there. That's how sensitive that is. Those cheaper, bigger beaded thermocouplers, they're not like that. We should get a nice profile arc. Okay, and once we get up there probably to about 210, we'll start nudging. I mean, we should break loose around 220 to 230, even 218 to 230. It just depends on the temperature outside, the temperature in here, a couple other factors. Got a gentleman blowing up my phone. It always seems like right when I'm in the middle of the most critical part of this process, 800 people want to blow up my phone. It's the oddest thing I've ever seen. I even sent him a text, told him I'm in the middle of reballing. You're sending me your unit to be Frankenstein, and right now you're jeopardizing another unit. So, you know, when we don't answer our phone, there's a reason for it. Okay, so we're getting, let's see where we're at. Okay, we're moving along. Usually we're gonna hopefully start breaking loose here in a few. Let's see, maybe I could stick you up here. Go, we're loose, so we're gonna stop the machine. We're gonna pull this and let's turn the pump on. We're gonna pick the chip, and while the board's semi-cooling, we're gonna get our solder iron going. Flux on here again. Okay, got my tip going. We're just gonna drop that on there. I'm gonna pull our thermal coupler back here. It's already got attached to a solder ball here. So we're gonna pull it back. There we go. See this? It just melts. It's a good thing. I'm gonna kind of just drag this around here a little bit. Pick up some of the old stuff. That up over there. That's another reason to use that tape. So you have somewhere to ditch the old solder. Let's put this down. More flux on it. Let this slowly pick up everything. Some people ask about the 4 little guys on the corner. They're irrelevant. Any proper rework, you don't need them. Balls on the chip should hold the grid up just fine. Okay? And that's a fact. I'm going to switch to the standard Kimtronics here. Shovel this down. A lot of times this method here, I mean, you got to be careful what you're doing here because things are hot. Yeah, you'll see a lot of people let the board cool and this and that. Well, I've been doing this so long that I know the temperature for my soldering iron and everything that needs to happen to make this work without causing a bunch of delamination and popped pads and this and that. Low melt really helps as well. Okay, so now I'm pretty happy with what we got going on there. I'm gonna go ahead zoom you in a hair there. We're still somewhat liquid, and I'm going to do this. This is actually moving some of the solder that may still be there or that needs cleaned just a hair further. Like this bottom corner here needs a hair of a help. So I'm going to switch my blade. And we could do this on the bench if we wanted to when we're inspecting the BGA site if we felt like it. But I'll just take care of it here right now. Get my tip warmed up. And we're working right down here on this corner. I kind of missed it. Not a big deal. This isn't my favorite soldering iron compared to my Weller. My Weller makes this thing look like a joke, but I've been using this to clean BGA sites for probably 10 years. So, like I say, once you find a process that works, you don't change it. Okay? And that's the bottom line. Okay. Now, we should be cool enough to go ahead. This should be a little bit tacky. So we're gonna pull this up. This all out of here because if you let it dry with the board, you're gonna have a mess. This pulls a lot of that rosin out of there. And we'll go ahead, turn the pump off, and we're gonna run the fan to cool the board. Okay? And meanwhile, we could kind of take a quick look at the BGA site if we wanted to, which is right there if I can find it. So it looks pretty good to me. Definitely we need to clean some stuff up. So we're gonna go ahead and pause the video at this point. And let the board cool a little bit, and we'll do the cleanup. All right. While the board's a little warm yet, we're gonna go ahead and do the hard clean, okay? This is no way, shape, or form the final clean. MEK, down. We're gonna use this first, just to scoop up what we can. Don't worry about the little lint stuff, that's nothing. We're just gonna go around here and get any flux. And this is why, I mean, yo, ultrasonic's a nice thing if the board needs it, but as I do this, I actually clean everything with the MEK, a brush, and we get it right. Okay. Now, here's my other workbench here. I always give these back to the customer. So we're gonna pull off this here. I don't clean them or anything. That's too much time, too much work for what, right? Put it in the bag. Throw it down with their paperwork and the rest of their console pieces. All right, now we're gonna pause again. Okay, so at this point we've removed the chip. I would say we're 20% done, if that. Okay, next thing I'm going to do is we're going to bring the board in here, do a BGA inspection of the site, and we're also going to do some probing on the board, looking for values that I know should exist without an RSX on the board. So I'll go get the board. It should be cool enough to do that at this point, and we'll go from there. Alright, so there's our BGA grid, looks pretty good. Flex IO looks good, no bubbles in it. That means our profile worked out pretty good. Now, I'm gonna use my $700 AI Gorilla Scope, which we're gonna take a little closer look at stuff here. I'm going to also slip this into our video. We'll do a recording here. Okay, now the scope's recording. So I'm gonna just put you over here for now, and we will slip this into the video. I'm actually just gonna pause you here because everything's gonna be recorded up on the cab. Or whatever. For realism, we'll leave it like this. We'll go ahead and eat the megabytes. So basically what I'm doing is I'm looking through here for any ripped pads, any pads with humps on them, that might make the chip sit awkward, delamination, bubbling, all signs of a novice profile. Okay? And that's all there is to it. I'm not going to say much more about it. You either know how to run your machine or you don't. And I'm going to tell you right now, it took me many boards to I had to burn up a lot of PS3 boards 15 years ago to get this correct. And I will throw out a pointer there to everybody, since, like I told you, I'm not really in the teaching game here. But, for example, profiles, environments change, things change over time. So I have this board here. See this? This says Rework Test Board. So, you know, about once a year, or when things seem a little off, I'll use this board to, and of course it's only good for so many rounds, because you keep putting flux under the chip, it gets nasty and it gets built up under there. But you can ultrasonic clean these and then keep using them if you want. Or every once in a while you're going to run into a board that just isn't worth the time fixing or something like that. But that's how we get our stuff set up. So now I'm just going to do some quick probing around here on 2-wire resistance, and I'm just going to look for any signs of problems. Okay, the V core is running up, which is a good thing. That means the NECs, sometimes I've done a board and it can't survive the rework heat, and the NECs will actually collapse and go to 0. They will short out, and you'll put a new RSX on there and be stupefied and say, well, I got a short on V-core, and you think it's your balls. It's not. So it's always a good idea to check this. If this was toning out or 0, removing the one or more of these NEC tokens would clear that. Okay? And of course we test this beforehand, so we kind of know. Okay, a lot of these should behave a certain way, and so far what I'm seeing, they're behaving exactly how they're supposed to. Okay, good. And the RSX test leg is running up. Okay, that's great. Right. This should run away, and a lot higher than it usually is. And then I always like to check the PLL over here, which that's perfect. You can check the V-core on the CPU if you want, if you get in there properly. And so here's the bottom line. Nothing's changed really, except for what would be expected when this is actually on there. So we'll stitch in the microscope video of the BGA sight, so I can show you exactly what a sight should look like if it's removed properly. Almost near perfect factory. Okay, I think I'm going to end this video at this point, and we're gonna, well, maybe not, I don't know, maybe I'll end it, maybe I'm not, but we need to find us a slim here. So I guess we could keep going on this video. Let me find us a slim. I'm going to put us on pause, and we're going to find us a working slim, and then we're going to harvest the chip from it. Meanwhile, this board does need cleaned in a few things, so it's not going back to the rework machine, but we're going to set it over here, and we will come visit it a little bit later. And there you go, DigiKey. There's $480 worth of poly caps in that package right there for your tantalizers. That's how we roll. Here's a couple that I've already made. We need to make 4 more, but we'll be putting these on this Frankie here after we make a couple more eventually. So we just have those back there. Some of my shop stuff. Here's my mini CNC for CPU donor board prep. We grind off the chips right down there. Here's some of my Weller stuff. This is my real soldering iron stuff here. Of course, you met the microscope already. We've got the, you know, the desktop voltmeter, oscilloscope, bench test supply, all the goods. I mean, we got everything. We sell a lot of stuff on eBay too. So, I mean, you know, when we need something, we generally just have it right in inventory. Even though, like I said, I used to have a big shop out in Wheat Ridge before COVID, and I got a huge contract for AT&T when they consumed the Cricket store. So we closed that shop because it was burning $10,000 a month and nobody was there. And post-COVID, I decided I couldn't deal with the public, especially in the gaming console community. People bugging me every 5 seconds. Is there shit done? Is this done? What's the prognosis? Blah, 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 blah. Where that actually creates more problems than letting me do what I do, my magic. Because every time you bug me, I have to stop what I'm doing and deal with you and then figure out where I was at. And I'm not trying to be an asshat about it, but that's the reality of the situation. So I feel a lot more comfortable. I make a lot more money doing structured cable and data center management, AV, commercial, home theater, access control cameras, you know, alarms, and software, point of sale systems with credit card residuals. However, I do love electronic repair, and I do this because I love to do it. And it's one of those things, just like my cabling jobs or my data racks, they're pro. Not one corner cut, because if my granddad taught me a long time ago, if you're going to do something, do it right or don't do it. So anyways, with that said, we need to find us a donor RSX 40 nanometer, and it's got to have a decent range of values. So we're going to move to that. I'm going to pause this and we're going to get that figured out. Alright guys, I went through some of my packages. I buy slibs almost once a day on eBay, at least 1 or 2. And so here's this one. Looks to boot. Got a picture. HDMI port's a little wonky, which for our purposes doesn't really matter. And we'll have our 40 nanometer that we need for this client fix. Alright, so we're going to break this down, pull the board, blow it off, and then I'll be back once we start prepping the board and we'll get it removed on the rework machine. Alright, here's the board selected. This one I just do, it ain't really a big deal here. We're just going to test a couple of little things here. I mean, this actually booted, so I mean, I don't really need to get nuts with it, but I like to just check a couple things here. That's a good value there, 245. That's about what I'm used to. And that's the V core ground. And let's check the V core there. That's pretty good, not too bad. By the time we're Back on the other board will probably be around 2.5 or so. So I'm pretty happy with that. So at this point, it's a matter of cleaning this up here. Paste is nice and wet. Console was a little ragged looking, a little beat up, but 5301 A1GB. It's good. Let's just put a little 99 on the top here. And over here where the thermocoupler is going to go. And need my brush. Do pretty much not as, you know, big time as the other one, but just gonna clean this up a little bit. Okay, clean this off here. So it's clean. IHS has got a little weird shit going to it. Okay. And let's see. We definitely want this on this IHS because we want to keep it from getting scuffed up or scratched or anything like that. We don't really care if we slice the board here, so we're just gonna get this off of here. Just like so. And since I've got two Jovies, so the deal is I do a couple graphics cards here and there, but my second Jovi I have set up just for RSX harvesting. So I try not to touch them because I do a lot of these, and having to readjust them every time is a pain in the butt. Alright, let me go grab the thermocoupler and we'll get that on this board. Again, Omega lab grade micro thermocoupler. Okay? I don't care what anyone says. All the other thermocouplers I've messed with, they're like 5-10 degrees off all day long, and they register slowly. So I don't like them really. So I shove that way under that corner. See that? That's actually in there. We could go here. Let's see. Let me see. I could probably show you. Scope level. I've actually jammed that underneath that corner. You see that? And that's the difference right there. Because when you cycle these, heat-wise, their values change. Now, I'm going to tell you, the way I do it, you lose hardly anything. It's not damaging the chip, okay, at all. And we're going to discuss something about the IHS in detail that other people refuse to even talk about or think about, maybe. I'm not sure which one it is, but it's one or the other. So let me get the tape for this, and we're going to take that probe down. Not that it really needs to be. And these probes are very good for removing chips. They're just as good for attaching chips, but you can't shove them under the chips. if that makes sense. You can't do that. Because, of course, these probes you can actually solder to a ball. So, you know, I mean, like, you know what I'm saying. It would mess the grid, the BGA site, possibly cause a short. Who knows? So, anyways, for removal, we're good. We stick it right in that corner. And we're going to go ahead and remove this chip. And we'll have the discussion about the IHS once I get this chip off and we do the actual reball to it. It's another thing. I don't know how other people do this, but I actually buy working slims. So I know where my chips come from. They come from a booting console. We can even pull the usage count off, all that good stuff, and know how much life this chip probably has left. And the way I remove them and everything I do, the pressure put on the chips themselves is near nothing. A heat cycle is always going to give you know, that wear and tear, but the more efficient and correct you can do that, I'm telling you, I've taken chips and I've tested all the points and recorded everything, and then rework it a few times. None of them values change. Now when you get too hot, values change rapidly, like the V core decreases, VDDIOs, things decrease or increase because they're opening or getting closer to a hard short. So those are things to be aware of. Why temperature profile is extremely important. And people that use rework machines manually, I don't know what to say about that really. I look at curves, and you can check my PS3 harvesting videos out and you'll see what a perfect jet curve should look like. Alright, anyways, we're gonna get this loaded up here with some flux, just like we did before. We need to put the flux on here. RMA Superior 99, and we're gonna float it through there. Boom, 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 boom. And put some at the top. Boom, 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 boom. Some at the bottom or the side, and then the bottom. And I already see it running down here. So once there's a little pool around the chip, that's generally good. Alright, I'm gonna take us out to the rework machine now. And we'll go from there. Now, I will take note that I am going to run manual on this, but I'm going to let the software control it, and I have an exact, perfect way to do this. What we're aiming for here is we're going to more board temp, hardly any on the chip at all, because we're going to tear the board up. We don't care about the board, we care about the chip. So we're doing the exact opposite of how we removed the chip from the A01 or COK001 board, where we went real light heat on the board and fried the chip on the top, right? Okay, makes sense? Still within a profile though that makes sense. And we don't care about jigs or anything here. I do have a bottom support on there, and we just kind of get the chip centered there, tighten everything down, just use the default Joby stuff, and that's pretty much good enough for what we're doing here. And one thing I need is a little dark over here. Number 3. Okay. All right. And I'm gonna just go ahead, and this video is getting a little long. I'm gonna kind of just pause this a little bit until we get closer to where we need to be. Okay, for setup over here, we just need our prod and somewhere to put our chip, and of course our suction. And I always make sure to wipe that off. Any little dust or anything on there can start causing weird problems. All right, so we're running here. And we wait. That's where we're at. We're waiting. You know, nothing special going on yet. So kind of wait, and I'll get you positioned for the pull. That's how we want the flux to be looking. Nice and bubbly. Plenty of flux. Cleaning all those pads and solder under there. Cut the oxidation to 0. Okay, we're at about 100 C. We got a way to go. I'm going to pause you again. That's how a profile curve should look. We didn't control the cooldown, and we pulled the chip, of course, so that went where it went. But yeah. Pull the board off, and let's go work on our chip before it cools down. That's the idea. Keep the heat cycles to a minimum here on these guys. if that makes sense. Do let it cool a little bit, nothing dramatic. We move it over to here. Now, first thing I look for is color of the chip. It's a good indicator of how healthy it is. And I use the scope for that, which we'll check out, but it should be pretty nice and green looking, if that makes sense. So all right, now we get the K-tip up and going. .400 degrees Celsius, and that may vary for your experience depending on what type of rework machine you got. Mine is high-end, so 400 is like 500 on some others, 600, who knows, but this is just what works for me. Put my low melt on there, put some flux, and get my K-tip out. Let me get this all warmed up here. I can always kind of tell, and once again we're going to talk about the IHS and delidding these, but generally I can kind of tell how good of a chip or how healthy the thermal paste is under here just by how my soldering iron reacts to this and the solder flow. Weird, huh? Not really. After a couple thousands of these reballs, it's easy to understand. So this one's pretty good. We're just gonna go around and clean up this here. All the old solder. Chips absorbing a lot of temp down to old, notice that old Xbox cooler. They come in handy for, I use these every day, these Xbox coolers. Using them for years and years. Chip can withstand quite a bit of temperature, especially with the Xbox on there, the Xbox GPU cooler. I'm going to run that off there, and we're going to start another bead here. The low melt's still pretty dirty, so we're gonna go for another round here. And we're having wetting problems, as in the solder doesn't really want to follow my iron, so we're gonna bring up the temp another 25°C, and we'll see what we can get going here. Yeah, that's much better. Solder is now following for the most part. Really get as much of the lead free off of here as we can. Which makes our wicking with our braid less damaging. I know most of this gets in the way there, the cam. Maybe I should have moved it, but whatever. Is what it is, right? So again, I'm just showing you some stuff here. Okay. Definitely right on underneath the die here. And sometimes if we lift that IHS up a little bit, in my opinion, leaving the IHS on helps the chip withstand the rework a lot more, as you can see, because I'm having this issue here. Which some chips do this quite a bit and others not so much, and there is the ones that do this, the thermal paste is hardly used, and there is no reason to mess with the IHS on this, and I'm going to explain that again in further detail. Okay, at this point it wants to fight us, so we're going to take it off of there. Yeah, I can just tell the thermal compound on this chip is pretty dang good, because usually I can get these chips to glide, and this thing is just sucking heat up massively. So that means the thermal transfer is really good. So, and well, like I said, I'm gonna discuss something with y'all about popping these IHSs off these 40 nanometers. The 65s, you know, it's a concern on them too. 90s, who cares on those, right? It's worth a shot. Okay. Absorbing enormous amounts of heat. Try to move you guys over here maybe. I don't know, it's hard to get you guys in position where my hands don't block it unless we're on the overhead scope there, but whatever. This is just part of the process. Can be slow going sometimes. Some chips just glide up and clean fast, others not so much. So the chip absorbs enough heat, it'll start gliding. Makes our cleaning a lot easier. You definitely don't want to move to the center at this point. There's no way it's ready. Sometimes leaving this solder on there just helps a little bit to snug up. This one's being a pain, which means it hasn't been, this chip has low usage on it. I'm going to tell you that right now, because the paste in it is sucking everything up. May even have to just remove this here to get some sort of result going on. So I'm sitting here fighting this. This is ridiculous. This off so we don't slip and slide. Oh, must be having one of those days, guys. You can clean these pretty simple. That's a fact. Oh, what the hell is going on here? But definitely don't want to force it. You may get, you know, some scratching on the chip, some things like that, but it's not always the end of the world. But we do want to try to keep things as nice as we can, right? So that's just my 2 cents on it. If it's slow going, it's slow going. It's starting to finally get there. I usually don't have to remove it from the Xbox cooler, but for some reason today we do. Which is odd because it's 100 degrees outside, so if it was, you know, 10, 20 degrees out like sometimes in Colorado is, I could see that because it gets a little colder down here, and we switched to winter profiles instead of summer. Gonna do one last cleaning. It still wants to fight me. So I got another method that I may employ here in a minute. 120 watt soldering iron having a problem here. Imagine that. It's a joke. There we go. But that goes to show you how well the heat transfer from the substrate through the die to the IHS is, because if there was none, if it was bad, this would be done pretty quick. This chip would already be burnt up, I can tell you that right now. But it wouldn't be burnt up because we would have already had it cleaned. There, now it's finally flat. So we don't need to go the other route. Sometimes I go. Now we can just go ahead and we're going to get this funk off of here. Set that there for a second. We're going to clean this. And we're going to let that start cooling. And I'm going to pause this while I clean up. Alright, we're back, guys. Man, and like I said, sorry about the video. And man, I ain't investing in no real streaming whatever video recording stuff. I mean, I'm just doing this, I don't know, just because it seems nowadays too many people run their mouth about doing this or that, and I mean, proof is in the pudding, huh? Like, we gotta show the video here, huh? So I do a test on this chip after it cools. So for now we're only doing one clean on it with MEK, but we'll do, once we do the board and once we confirm the board and the chip is in good shape, which we know the board is, we've already done it, but we need to let the chip cool down a little bit because it won't read properly when it's been baked like that. if that makes sense. So for now, we just leave it clean like that. One thing I do like to do is I flush IPA through and under the IHS and blow it off. Blow it out. Get any debris out of there, flux, stuff like that. And going back to, why don't you remove the IHS? Why don't you remove the IHS and just do that? Well, I'm going to tell you here in a minute. Alright, I had to stop that video. I couldn't flip the camera around. So, about the IHS. So, I see everyone out there, man, they're hammering razor blades in there, mini crowbars, this, that. Here's the bottom line. I have a buddy of mine. Okay, I do a lot of work for him. He owns a data lab. He has an x-ray machine. We've done the x-rays. I don't care how careful you are damaging the substrate. Even if you don't crack the die, which is don't crack the die, because then you're really in trouble. But you are stressing the VRAM bricks. I don't care. The underfill for them to attach the BGA bumps to the substrate, the epoxy, they're all stressed. The substrate itself is actually squished. If you try to crowbar with a mini crowbar and pop it up after heating it, there is a way to remove it, and it's kind of pricey. And we don't remove the IHS unless we are getting above about 55C on the RSX. And if we are, I have my own method to do that. And I mean, bottom line on that particular method is, I mean, it's really of no one's concern how I do that. But we can do it, but we don't unless it's absolutely required. Generally, the Slim RSX, it's like 10 years newer, okay, depending. And, as you can see by just cleaning that chip, it's absorbing massive amounts of heat from my Weller's 120 watt K-tip. Okay? There's no need to do it and risk. Even if the chip looks fine, there is internal damage. I have x-rays that prove it 100%. So we do not do that unless it's absolutely required. These other people, I mean, you're more than welcome to have them do your Frankies for you, and go ahead and do that. And I've repaired a lot of Frankies that looked to be Frankenstein right, and guess what? The RSX was dead. And again, I don't care. The results are starting to flow in. People found out about this, back in 2021, 2022, something like that. I didn't get involved till just recently, last year. And I mean, I've had 0 returns. I mean, 0 warranty work. And I keep in touch with most of the people just to check the status of their system and how it's running for them. And at the price point, trust me, if something goes wrong, you're going to hear about it. And so the bottom line is, we don't delid IHSs off of the RSX. The cell, we do those no matter what. Those always come. That's soft. It's not even really epoxy. I mean, it is. It's a rubber-based epoxy, and you take a sharp little. They have a tool that a genius made, and that's what we use, and it comes right off. And undervolting both the cell and the RSX dramatically reduces 510C. So by the time I'm done with the system and my RSX is running at around 52C, and I compare it to someone that's delidded, pried something off of theirs, took a chisel or a hammer and a razor blade and just decimated the chip, whether it be on board or off board, doesn't matter to me. I know the fractures are there. It's a fact. And I mean, what, to give 48C, 4C difference? It's not worth it. Now, if our RSX, after we put it on, runs high, like 65, you know, then we will go ahead. I use a chemical cocktail that you just let it soak, and you'll get the result of the lid just pops right off. So with that being said, that's where we're at with the delid on the RSX. Don't ask me to do it, because I won't do it unless it's absolutely necessary. 100%. The 65 isn't as big of a concern. We've been able to get those off with minimal fracture into the substrate and BGA bumps. Minimal, but still, it happens. Same with the 92. Just because they pop off easy don't mean you ain't stressing something and putting stress fractures and things. It's real life. So, you know, as far as, you let me know any if you got an x-ray machine that can deduce that, because I doubt you do. All right, we're gonna pick up on testing the chip and reballing it, and then moving to put it onto the board, and we'll do that here a little bit later. I'm going to end this video because I'm going to go eat some lunch, maybe kick back a little bit. It's Saturday, so we'll see when I get back to this, but we will continue this video, and that'll be that. Okay guys, got back from lunch. We're going to move on to testing the chip. This test, I mean, this is just something someone came up with. I have another test that I use as well. We're gonna do it all, but here's kind of what we're gonna probe here. And of course, this doesn't really tell you what values to expect. That's just gonna come from experience. I know mostly in my head what's acceptable, but also I have a spreadsheet of chips that actually worked and didn't work, and I'm talking hundreds of them. Not hundreds of them that have worked, maybe like 10, 20 that haven't worked, if that makes sense. So I'm gonna start probing this. And I'm going to work my way around. I usually start at the top left and go down and to the right. So we'll go ahead and take a look at this here in a second. Let me just get my chip situated. And we're going to do some tests. Okay, that looks good. Looks good. That looks good. That looks good. Let me see if I can get on here. Here's our V-core. So it's 2.7 on the board. So we didn't lose much. It actually, this chip is looking pretty good. We got one more point to test here. Let me move the chip under the scope. And it's looking good. And then I got another little test I like to do. That looks great. V-core again. V-core again. Reverse. And yeah, okay. This chip looks good, guys. So we're gonna do some more cleated on it. What we're gonna do. So let's do that. Since we've been handling it, we're gonna go back to the beginning. Hit it with MEK first. Yeah, we're gonna scrub that up real well. Go around the sides. The top real quick. Okay, there's the MEK. And we're gonna move over to acetone. Let this sit there for a second. Just that's squeaky clean. Cut. Now we're just going to put this in here first. Jig's been cleaned from last use. I get into the scope here and verify. I will record what I'm doing under the scope here. And I'm just verifying, since this is pretty much the jig I use over and over. Rarely doesn't need an adjustment, every once in a while. Right now I'm seeing a possible little adjustment I would probably like to make. Let me get the right driver here. Let's loosen some of these up a little bit. And sometimes that's just from the tape that I end up using. Sometimes it just kind of shifts the chip a little differently in the jig. So I like to always check this and make sure it's pretty close. It doesn't got to be perfect. Pain in the butt sometimes, especially with using the microscope, because I mean you can see a lot of people that do this type of work don't necessarily use a microscope. I know I sure didn't 15 years ago. My eyes were better, and you could call it, but a lot of this stuff, you could see a lot of problems under the scope that you usually wouldn't see if you were just going regular eye socket, right? Okay, so there's basically what we're looking for there. And we're gonna go ahead and pull the top off, and we're gonna double check some stuff here. This, I like to make sure I don't have any excessive light on the chip. And we're just kind of looking around. Once again, I've already done this a few times. Okay, looks pretty good to me. So now we're gonna do the final cleaning on the chip. And we're going to use 99. We can get one of these and one of these. This is like a super lint free deal here. It's a foam cube block. I use these a lot on cell phone and micro stuff, but this same thing works great here, right? Okay, so let me get the 99, and we're gonna put a little bit right there on the chip. Okay. And I'm just going to soak that up, run it around the chip there like that. Nothing dramatic. This just cleans off any residue from the harsher chemicals in my mind. The IPA is a nicer finish clean. But MEK can do it too just fine, but I've always done the 3 chemical cleaning process, and I'm just going to stick to what I do. And just do that, and that's pretty much all we need to do. And then I'm going to put my top back on, make sure nothing's really changed too much. Now, for some of you guys, one of the harder things about reballing chips, I'm gonna teach you something. I'm gonna teach you something that 20 years of experience gets you, because it's one of the harder things. How much flux do you put on the chip so that the balls stick but don't turn into a skating rink? Well, I've almost got it to the point where it's almost perfect every time, and so I'm gonna show you what I do. It's I don't know, maybe other people do it. It's a combination of things I've done testing over the years. I'm an old school. I use the King Bow. I use King Bow on everything. It's cheap, works, and I mean I use it on $10,000 AI graphics cards. They work just great, just fine. Nothing wrong with this stuff whatsoever. I've been using it for 20 years. I've taken chips off after 10, 15 years, and there's no BGA degradation, no nothing. This stuff, it's fine. It's exactly what we think it is. As long as you get the legit stuff. I source this from a real place. I mean, it's gotta have California spelt wrong. Okay, that's a big one, and it should look white, not like pee or Vaseline, should I say. Okay, we're gonna take a quick pause here and get ready to reball this chip, which is, my process is a little bit more than most people. I don't use a hot air one. That's amateur stuff. All right, so my little trick is pretty simple. Need a few things here. We're gonna open this up. And first thing we're gonna do is I'm gonna warm this chip up a little bit. Not very much, just a little bit. About like that. And I'm going to take some king bow and I'm going to rub this around very liberal like. And of course, if you were to try to put balls on this and hot air won this or anything, them balls would be all over the place, merging together, floating on water, hydroplaning, right? Pretty much. Now, we'll go over it again. I'm going to let that conform. Okay. And then I'm going to take this. Basically, it's kind of like a credit card. And I'm going to go totally flat. And come right across that. Wipe off the excess. And then I'm going to turn it this way. Come across totally flat again, and then we're going to go back under the scope here. I run it two ways, with light and without light, to look at how things are looking. Look for excess. It should be pretty even. Okay, should look pretty good. Okay, and then I like to take a look. Without that, and I'm somewhat happy, but I think I'm going to we'll go ahead and reactivate that one more little time here. Take another look here at this. Okay. I don't even think I'm going to swipe it again this time. This looks pretty good to me. Okay, so now here's the trick. Got to wait a few and let that chip and let the flux totally cool down. Okay? Otherwise, when you stick the stencil down on there, it'll get stuck to the chip. So let this basically harden, and that's what heating and activating that does, is it's going to get that on there where, and you let it dry, and it gets super tacky. and when you reactivate it, it doesn't go like liquid water and start floating all around the place. That's with my flux anyways. You guys use whatever you use, and maybe it works, maybe it don't. This is what I've done for a very long time, and we'll see what the result is. Sometimes it's great. So, I mean, you know, there's problems every once in a while, and we can address them when they turn into problems. But for the most part, we're checking it out. Okay, we're gonna go ahead and put the so on there. Make sure it's lined up again under the scope. Okay, great. I broke my bottle of balls, so I got them in a little zippy bag right now until they're gone. I don't mess around with reclaiming balls. I put plenty in there. The excess go into the trash. That's how I roll. The micro tweezers out. Roll the balls. Take a quick look. My old eyes don't work very good. Discard those. Long time ago I used to save the extra balls, but I find they cause more problems than anything. So then I just go over the stencil again. Make sure everything's filled in. Great. Tap, 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 tap. Lift. And we're going to take a look here. Our alignment is pretty good. Sometimes under these scopes it looks like you might have a piece of debris. That could be the fact. So grab it. Then I like to look at this with the scope off. We have one ball that's always extra right here. Get rid of that. And things are looking pretty good here. I don't think we'll have a skate rink problem. You see how that flux looks like a solid layer? I mean, there's a couple of places with a lump of flux, like here, but we're not going to worry about that stuff. It's minimal. There's a couple spots there, up there. Corner likes to do that a lot. And over there, because the chip actually dives down. Or it's probably from my card in the stencil, you know. This ball's a hair off here. It's not like end of life stuff. There. Okay. It's good enough for what we're going to do. Alright, so now I'm going to pause this and we're going to take this out to the proper piece of equipment to attach these balls at a controlled heating cycle, a controlled rework cycle properly. Alright, so we're over at the chip hot plate. Turn the smoke absorber on, and what I like to do with this is first we're going to get the chip on there. Okay. I'm gonna pick it up. I'm gonna put it on there. And since we kind of moved it with our hands, I'm just double checking. And everything looks great. Okay. So I'm happy there. We're going to turn this on. I'm going to turn this down to about 150. And I'm going to close the lid. And you ask, why 150? Well, generally, what can happen is if it's going to turn into a skate rink, right? If it's going to around 140, 130, something like that. And if it does turn into a skate rink, we can go ahead and pull the chip, let it cool, and the flux, some of it will have burnt off, mellowed down, toned down, realign any balls that may have moved, and then we can go for a second shot. But I've been doing this a while, so we should see a good result. I'm gonna go ahead and pause this, let this get up to temp while I go clean up the jig and stencil. Okay, so we got clear to 150. I got two balls that are acting stupid. So we're gonna fix them. I'm gonna try to fix them right here. We'll pause the video. Gotta be kind of fast because this heat sink's only gonna protect me for a second. And sometimes this is too much, and it's easier just to take it over to the microscope. Sink's done. It's too hot. And being a pain in my butt, so may have to pull it. I'm close, but one of them things. Okay. And Alrighty, that turned into a nightmare to a point, and I'm gonna tell you a funny story about this. I've had chips that go beautiful, one shot, done deal, and I've had chips that have turned into a straight up nightmare, and I figured there's no way in the world those are gonna work. Well, guess what? The ones that go easy, they seem to not work. The ones that want to fight you, they always work. The ones that just sometimes just go boom and work on attaching the balls, you know, a lot of times those work, but I mean sometimes things go so smooth you're like, yeah, that ain't gonna work, you know. It's funny like that, how that is. So we're gonna start heating up again, and we'll see what happens. I had a couple of balls skate. Probably in them sections it showed like that little amount of excess flux. And then when I went to try to fix it on the hot plate, I accidentally touched the corner, which moved about 5, 6, 7 balls. And that just turned into too much. It's easier to pull it off and just move back to the scope, get it realigned, and we'll see what happens here. And this is just phase 1 on this. What we're doing is we're getting the balls onto the tin pads. Sometimes, like I said, I mean, I've had it where everything happens just on this pass. But I never trust it. After this chip cools down, we're gonna take a brush and we're gonna scrub it and see if any balls fall off. If they do, the pads that are, we're gonna inspect them and clean them and reapply balls to those sections. You know, if things go right, no balls fall off, we apply a thick amount of flux and run it back through the machine, and we get what I call the tin hut, where everything comes together. I'm gonna have to move you guys because I can't see very good here. Okay, I'm gonna pause you. Alright, this chip wants to go the hard way, so that's fine. The ones that really fight me, they always work every time. So we'll see. We're gonna let this warm up again. I have to adjust another ball. Got apparently just a little too much flux, or sometimes you get a pad that might have a slight hump to it, and when you glide that card over it, it leaves a pocket of flux, and you've seen some of that in the scope in the video. But you know, like I said, this is part of the game, man. Deal with it or don't. It's up to you. Sometimes I could get these in one shot, sometimes they turn into a nightmare, so we'll see. We're gonna let that warm up again and kind of see what happens here. Balls are kind of conforming. I'm going to take it up to about 180. Next, see if they stay placed. And I'm also running out of storage on the phone. I'm gonna have to dump our videos, stitch them all together. Like I say, I ain't some producer here, influencer that does this all day long instead of getting things done, so it's a hassle in my mind, but I don't mind showing you guys what's going on here. So things are looking pretty good. One little ball there I would like to didn't mean to pull it off, but oh well. It's acting weird. So that one we'll have to put back on. But we're gonna move up here. I go to about 200. Okay, put you on pause. Alright, I said screw it. I went back and put that ball on there for us. So this is a matter of, this isn't rocket science. You got to get all the balls on there. They got to be uniform and do what I call a 10 hut. So that's what we're after. And once they're pretty close to uniform, we're going to let that sit for a minute at 200, about, I don't know, 2 minutes. So I'll put you on pause till that's about over. Alright, good enough. Now I don't put this on cooldown because by the time I'm done doing what we're going to do, it'll be about at the temperature of the chip, because we're just going to go back on there one more time. And we're going to flood this with flux. So let's go over to the bench. Put us on the scope again. Okay, and I'll put this up so you can see what's going on here. We'll stitch that in a picture-in-picture window. Right now I'm just looking around for any alright, so what I like to do after we get off that hot plate is I like to run over my grid for any balls that are loose, missing, acting stupid, because there's always one. Well, not always, but this chip didn't go as good as some of them, but they all get where we need them to go eventually. Okay, so that worked pretty good. And then I just like to do this. Okay, that's how I roll. And then I check under the scope again, and I'll fire this up so you can see what the balls kind of look like currently, and then we'll be able to see them once I finish what I call the 10 hut. So some of the balls, as you can see, are not perfect. They're not necessarily on their pads. They might be to the left, right, but for the most part, most of them are. Some of them aren't. And that could be bad from not cleaning the pads as good as they possibly could have been cleaned. Okay, but that's not end of life. That's part of reballing. That's how the game works. It's what it is. Okay. I'm out of juice for the most part. Let me change out. Okay. And here we go. I'm gonna lay some flux down here. Just like that. You guys think that's crazy, huh? No, it's not. Like that. That all over the chip. Okay. And we're gonna do our last run under the scope. I'm looking to make sure all balls are pretty much submerged. If not, the area that isn't, we go ahead and we're gonna put a little bit of flux. Get it on there like it should be. Okay. It's important because if these balls cannot stay where they're supposed to when we do this on a hot plate, then what do you think is going to happen when we put it on the board and try to solder it back to the board? What do you think is going to happen then? They're going to collide. So this is why I do this way. I flood this chip with flux. And so you'll be able to see what I'm seeing on the scope video that we picture in picture into the video. Okay, now we're going to move back over to the chip hot plate, and we're going to run this through there one more time. And the chip's about the same temp as what the hot plate is. I've got that down to kind of a science there. So we just turn it back on. And we're going back to 200. Could leave the lid open or whatever. I don't know, maybe you can see something. Here, let's see. Oh no, my eyes are so bad, who knows anymore, right? Plus, I'm not recording in an 8K Ultra, so that's a lot of wait time. We're at 135, we gotta go 200, so I'm just gonna pause for a little bit and we'll check back. Okay, we're at temp 200, and from this perspective it looks like all our balls are in order. So that's good. We're gonna turn that off. I'm gonna go to cool mode, and I'm gonna examine this under the scope, and you guys will be able to see that here as well. I'm going to pause this and we're going to take a look at that and see what's going on. Okay, everything looked good, so what I do is I leave it on this heat sink and I close this up, and we'll be getting ready to put it on the board, the motherboard, reattach it, and get ready to do the rest of the Frankenstein mod. Resistor. We'll do the resistor and the syscon training data after we put this on. Make sure it turns on. If that looks good, we'll go ahead and run the 0.95 hardware VDIO mod to drop the voltage on the chip to the correct voltage it needs to be. That's where we're at. So I need to also offload my I'm running out of recording room on the phone, so I'm gonna take care of that, and we'll get back to the video here in a bit. Okay guys, we're back. We're gonna clean the board BGA side up here and get ready to put this chip on there. So get that ready to go. Not a lot to it. We already examined the BGA side. It's good to go. So we just want to make sure the pads are nice and clean. I didn't see any oxidized pads, so we look pretty good. Checked all the surrounding components, which we'll do one last time here, and make sure things are looking good. So MEK. Acetone next. I like to clean this Flex IO area here. Because we're going to tape our probe over there. Kind of basically do the same type of cleaning we did with the VGA chip. Some 99 on there. Nano sponge. See, that nano sponge is literally like foam, so no hair, bristles, horsehair, whatever from some of the other finer brushes we got. I mean, I use these brushes here, which these are ESD. These aren't toothbrushes. I mean, I guess you could brush your teeth with them. A new one maybe, but these are ESD fine bristle brushes. Okay, so we got that. I'm just gonna do a quick look at the site one more time. Everything looks good. Just blow that off after cleaning. Okay. Do the micro probe. We're not going to be able to, of course, get this under the BGA chip because it would actually solder to any of the balls, cause merging, whatever. So we're going to tape it down as close to the site as possible without interfering with anything here. A little too close. That happens. It's very hard to see for the most part, but that probe is right there. It's just on the borderline. That little tiny nub right there is the little head. Good enough for what we're going to do here. Now, one thing I do, because this tape sometimes let go when heat and flux come together, is first off I'm going to heat the area because we're going to put some flux down. So once again, I like the flux spread evenly. A little bit of heat helps with that. And heat this tape up. It also helps dry out maybe any IPA that may remain or anything. And it gets the flux introduced with the probe and tape. And you think, well, gee, you put a lot of flux on the chip. Look, on attach, if the balls are attached to the chip, this stuff, it don't matter. I mean, you could put a gallon of flux on here. It's gonna heat up and go flat. So generally, I like to just do this. That's how I do it. Other people can do it how they do it. I do what works for me. Like I said, I found a process that works over and over, and that's what we do. It's the same process every time. Okay. So after I do that, I like to go around the perimeter, just make sure flux made it all the way around. It should be a little bit out of the BGA site. And everything looks good. Alright, so we're looking pretty good. Alright, I'm going to pause you and we're going to get out to the rework machine. Alright, we're on the rework machine here. Get the laser up. And load the attached profile, which is a lead profile. Okay. Okay, we got our chip from yesterday that we reballed. This one's pretty, I mean, my eyes are getting pretty old, but pretty straightforward. I'm putting this chip on here because unlike some boards or things made by like Apple, they don't give you any way to determine the lineup except for surrounded SMD components and actually fill in the chip block in on the grid that was cleaned. You can fill it a lot of the time. Just lock in. And this grid is a lot more unforgiving than smaller grids and chips, if that makes sense. So, but I always still spend time on this, like it's iPhone CPU or anything like that. I try to get it as close as possible. And basically, those 4 pads that are on here that held those SMDs on the 4 corners, that's your goal. Just get that lined up with that, and you're going to be in pretty good shape. Okay, so there's that. Our tape isn't touching the BGA chip. Set our heater here. And we'll need the push rod. Take the smoke alarm down, and that profile, if any interest to you. And we're gonna Turn the safety down to 200 now. We're gonna get this chip up around 195-ish, something like that. Give it a nudge, and we'll go from there. Okay, so we're gonna let that run. I'm gonna pause this for a little bit until we get closer to our goal. Okay, around the soak-in temp 165 is when the soak-in is, but we'll definitely be back around that temperature, 170, 180-ish. Okay, we're moving along. I'll try to get you a chip drop view here when we get a little bit closer, so I'll probably move you over here in a little bit, start seeing what's going on over at the chip section. $165 or soak is gonna be done. Which a lot of people wonder, what's that mean? Well, the soak, we put top heat on the chip and let it kind of not extremely a lot, but just kind of get the chip warmed up, ready to go full throttle to peak, where we're gonna really introduce top heat. So from about 160 to 165, it's kind of gonna, I've got it set where it kind of slows down there. Okay, so we'll be getting close, so I'll try to, let me see. Every time I try to zoom in, this phone doesn't have great deal here, but we'll see. Who knows? We'll leave you there. We're gonna nudge this chip too once it's liquid. You'll hear the alarm at 180, and we're gonna go to about 190, 195, something like that. We're gonna let it, all that super amount of flux, we're gonna let it wet up real good. Looks like the chip dropped to me. I'm going to give it a few more. And we're going to give it a nudge here. I like to nudge it in the middle, one corner, another corner, and then back. And it should spring. That's all there is to it. And we'll stop the profile. Remove the top heat. And I let it come back down to about 180, and then we'll turn the fan on. So we got about 10 or 12 C. We're just gonna let it, it's sitting there. Things are still molten, wetting. Gonna let it get down, and then we're gonna go ahead and run the fan to cool the board. And then we'll go ahead and, once the board's cool, we're gonna probe some known points, look for any shorts or oddities. And if all that looks good, we'll do the resistor mod, syscon programming, input the training data, and go from there. Okay, that's good. We're gonna run the fan, and at about 160 I'll pull this tape and the thermocoupler. Want the board to kind of cool down 2 to 3 C every couple of seconds, ideally. This is a big board, so the fan does what it does. But that's a good cooling rate. We don't have the curve going right now, but because we got to stop and nudge, so it's a little bit different how we do. Okay, so right there we're going to be good. I'm going to go ahead and pull this up and remove the coupler, and now it's just a waiting game. Let this cool down, let the chips cool down so we get accurate readings. So we're going to pause, and I'll be back with you guys in a little bit. We'll be on the other bench. Alright guys, we're back. The board should be cool enough to do some probing. We're going to clean up our VGA area around the chip real fast. And get it cleaned up. Let me clean my brush. And that's why I put that on that IHS, that Capcom. Makes it not get all nicked up. Okay, so the geniuses have this for us. The values really don't matter to me because I rarely see any of these values. I have values in my head that has been consistently what I see over and over and over on working boards. Even sometimes they're different on working boards. There's play in them. So we're gonna do some probing here, and we'll see what we get. Oh, that's great. And this is a normal value I see over and over and over. This is the V core. Look at that. We're real close to what it was on the slim board. It means the NECs are probably okay, and we don't need to replace them quite yet to do a test boot. And this value is 100% okay. This value is correct without the resistor mod. Once you do the resistor mod, it goes up to around, I think it's 84 or 88. Can't remember. And this value is correct as well. Let's check the CPU V-core. It's a nice good one there. Let's go over on the RAM. It's good. And the PLL on the CPU. That's good. Everything looks good. Good enough to proceed with the resistor mod. And training data in the syscon. So that said, we're gonna take this off the jig, and after we confirm we boot, go ahead, delid CPU. Well, we won't delid the CPU yet. After we confirm boot, we got to do the resistor mod, syscon training data, and then once we confirm we got boot, we'll go ahead, do the hardware level VDDIO voltage mod down to 9.5. Once that's working, we'll do the tokens. I'll show you how I do the tokens. I got a smooth way to do those. Bare minimum here is resistor mod and training data to get this sucker to go. I will get the scope going on this here as well. Gonna need it because you won't be able to really see what I'm doing here. First thing I'm gonna do though is just clean this board up a little bit. I'll clean it a lot further. I'm just cleaning my area where I'm gonna work and where I have worked. I'll probably take care of some of the factory flux and stuff here. A lot of people I deal with, they don't want to spend money on a ultrasonic. They'd rather spend that on a hand wash, polish, and buff. So anyways, once I know this board is in working order, I clean this all up anyways, all of it with MEK. All this factory flux, everything. So you kind of get a hand wash of the board included in your Frankie base package. Okay. So, alright, the video got cut off. Someone text me. Anyways, we're gonna move. We need to do these two things here. So we'll get these going, and then we gotta do the training data. I'm just showing you this. We'll do this under the scope, and so that's how we're gonna do that. It's under the scope. And we'll get this recording, and we'll add this into the video. Oh, I need to put an SD card in that thing. Hold on. Okay, I got the iKon all set up for access. We got the wires hooked up. We got the power supply. Okay, we did the resistor mod. So we're gonna go in here and I'm gonna try to hold this for you while I do this. Okay, run the off to get in there. Oh, I forgot to turn the power on. Beep. Okay, Control C out. Off. Okay, now we're just gonna basically copy and paste the 40 nanometer right in there, right like this. Boom. And then we'll have to run the EEPC sum, most likely. We'll see. Okay, we're going, enter EEPC sum. And actually, we're fine, and that's because I might have pre-programmed this chip in there. Sometimes I do that. I didn't show you the iKon when I pulled it. Sometimes I already know what I'm going to do. But we definitely wrote that. We did that. Now we're going to do bring up on this board. Now we're not going to keep it up too long. What we're going to look is for a power sequence failure, okay, or something of that nature. Generally, I'm just going to bring it up for a couple, and we're going to see if the stages are correct, and then I'm going to hard kill the power. And we're looking real good. So I turned the power off, okay, and now we could do the undervolting in the iKon, but I like to tweak that. So now the next move is the hardware mod. So to get the RSX down to 0.95. So we're gonna pause and we're gonna get this back over the bench here in a minute. Or I mean, we don't have to pause. I don't know. I try to conserve my space on the phone. I don't have a lot. But anyways, we're gonna take this apart. Okay, there, it's apart. See, take that off. There, we need to remove them wires so we can work on the board. So I'm gonna come back over here and I'm gonna remove them. Having a hard time. Now, this is why I don't usually do the recordings. It's just a pain in my butt. But I'll prove to y'all what's going on here. I'm sure some yokel will be like, oh, that ain't the same board, or that ain't the blah, blah, blah. Everybody got something always to say, right? Okay. Now, we need to work on this guy right here. Okay, right there. See this? We need to do some work there. I could show you. Let's see. I think I got the thing in here somewhere from somewhere. Let's see. Yeah, here it is. So here's what we want to do. Okay. Right, so basically we're gonna get this done here. Okay, so we need to remove this, and this. Okay, so I'm gonna work on the chip first. We're gonna fire it up in the scope. I'm gonna go take a cigarette break and we'll get back to this and work on that. Okay, we're back. I got the scope rolling. We'll put this in the video. Okay, so everybody does their things how they do, and that's fine and dandy. I do my stuff more like iPhones and things. I'm not gonna fight this, so I'm gonna cut the legs off that chip and just remove it. One thing we're going to do is we're going to remove everything that needs removed, including the NEC tokens, and we're going to put everything back on one more heat cycle. We're going to do it all in one shot, so heat only goes to the board one more time, and that's what we're going to do. Okay? Let me get my grinder going here, and actually before we do that, I'm going to remove the SMDs because I like to put a little bit of flux down. That'll soak everything up. So we're going to go ahead and pull the SMDs first. Yeah. A couple that need to be removed there. Okay. 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 There's that one. There's that one. I thought I got it. Didn't quite go, did it? Acting like it wanted to. Just being a butthead. Yep, okay. Put a little bit more paste on there. Or a little more solder. Come in right there. Jeez. Okay, guys, I had a side tour yesterday. Had to go take care of something, but we're back on doing the voltage mod and removing the NECs and some stuff like that. So I like to just grind that chip off. It's easier for me. Remove the resistors. Put some flux down here to capture any debris here. So here we go. This is an easy way to get the chip off if you know what you're doing. For me anyways, without getting heat involved. We're gonna try to take care of the NECs and this all in one go. If you're not used to, I do a lot of chip polishing on iPhone screens, so I mean, if you're not careful, you can definitely make a permanent mistake. I mean, it can be corrected usually, but that ain't for everybody. To each their own how they do things, right? I mean, we could put this on now, but I like to, I'll do the little SMDs now, but I like to do the actual regulator when we do the NECs, because we'll just heat that area, it'll jump right on there at the same time. So I find that the best way to keep heat on the board to a minimal. So need 1.8 and 3.9. So we'll do the 1.8s first. Clean all the pads up here again. Okay, there's the 1.8s. Let's go ahead and 2.9s next. Whoops. Ah. Okay, that last one's starting to mess with me. I'm gonna switch or tip. I like to use that micro K-tip, but sometimes it's a little too much. Could just use my hot tweezers, but let's do it the hard way, right? And we'll reflow that whole area with hot air. Everything will jump on nicely. It's a little dirty. Let's go ahead and clean. Clean it up. Get some of this stupid padding that's on these NECs. Let's get that off of there. Just creating some Emmy Okay, eats it alive there. It's all over my brush. Alright. Okay, whatever. Let's go ahead and clean that area up. My brush of cleaning. Okay, that's better. Okay, back to what we were doing here. And now we're gonna flow this with hot air. Down here and get these a little bit. Okay. It's pretty good. Okay. Let's move on to removing the NECs. That's the next step. And we're going to do that in a minute. Alright. I've seen a lot of wild stuff for removing the NECs. It's pretty wild, man. I'm going to use basically this. This is a razor sharp blade. I mean, I literally on iPhones can take this blade and literally just scrape the CPU right off the board. It cuts the BGA grid, everything right off the board, perfectly flat, doesn't harm the substrate on the board or anything. So this is what I use to get these NECs off of here. So we just go over here, go right underneath there, start wiggling a little bit, avoid your components. I have a certain way I do this. Go on that side there, just crank that up, and then come over here. See how easy that comes off? I sell these on my store on eBay. Be pretty careful with this thing. It's sometimes it'll take off on you, so just be aware. I'm used to it. I know how it works. And you might ask, like, why aren't you using a jig or this or that? I'm not pushing down on the board. I'm pushing that way. I'm not pushing down. So there is no need for any of that. Sometimes you'll get a little piece of debris left there that sometimes is hard to see. When I say razor sharp, I mean this is like my scalpels. This thing shaves these right off. It's a very good tool. So see, sometimes you'll get that little leftover piece right there. Okay, not to worry about that too much. When we heat this up, we're gonna flow all these with tin solder, lead free, to attach the tantalizers. Alright, and we'll get to work on, we got to build 4 more tantalizers and prep this area, and we'll be getting ready to do the voltage regulator and the 8 NECs. Alright guys, we're back. We're going to build the tantalizers. Okay, let's see here. These in order here. Low ESR. See that? The good stuff. Just get these in order, which I should already be, but okay. Okay. Alright, so we got those. We'll need the regulator. Let's see, I've still got some poly caps in here. I already got, remember, I built already 4 for, these are left over. When I got time, I build these up. So we need 4 more. 4 times 3 is 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, it's brand new. Not from Slim Boards. Brand new, high quality. And we'll go ahead and we need our little chip too. We'll put this over there. Okay. Now, go over here. We're going to go ahead and get the tweezers out for this. Let's see, we need a different tip to tin the tantalizers. Okay. I use 1/38C to build out the tantalizers. So we'll get them built here. I got a whole bunch of them right here. So I need 4 of those. Fluxed up. Right. Okay. And I'm just going to tin them. Have to go get my old man spectacles. And that one pad wants to mess with me there. Good enough. So yeah, and I like to just build mine. The ones you buy, you really don't know what people use or corners that cut to make a buck, right? These, I know what they are. I know the grade of them, so I like to do it, just to be sure. Could save a lot of time by just buying some pre-populated ones, but that's, I don't know, like I say, people do strange things. A lot of the YouTubers, not sure if they're influencers or just trying to push their product, you know, I see them pulling components off of the board they're working on for like that resistor mod. You know, they take it from some location on the board. Well, I don't know, an engineer put that there for a reason as far as I'm concerned. So just taking components off a board and moving them around don't make sense to me. That's why I showed you I got all the resistors and all the capacitors we could possibly need to get this done right. And we know where they came from, we know the quality and all those good things. So I'll just stick to what I do, how I do it. Some people talking smack about because I generate some images with AI. I used to do graphics art. I used to make a lot of money doing websites and graphics, and I spent 3 days creating a logo. Well, why? I'll just have the AI do it in 30 seconds and we can continue on with real work like this that matters. And I get people saying, oh, that's cutting corners. I'm not, you know. Lo and behold, I actually am a graphics artist. I know how to make graphics. So, but I just find use the tools at your disposal to get the job done fast and efficient, right? That's what makes sense to me anyways, and everybody else can cry and complain. Just like I had someone on Reddit talking smack about my logos, and then another Frankie builder wanted to interject and start asking why my listing, or why my Frankie should just be a flat Frankie. It requires this, this, this. Well, that particular builder doesn't offer drive upgrades, enhanced cooling, fans, power supply upgrades, undervolting, any of that. And maybe someone wants a 65 nanometer because they like to run other OS on their console. Or maybe the Frankenstein was partially done and it just needs something else finished. That's why my Frankie listings, or when you do Frankie with me, we can, I mean, there is a bare minimum requirement. You need the base package, which is what most other sellers offer, and that's all you get. You know, you need the voltage mod, NEC tokens, delid, and tantalizers. You know what I'm saying? I mean, there's a base package. So people can talk all they want about, I mean, why they're concerned with how I sell, I don't know. I've been in business for 30 years. I own 3 companies. I kind of would assume I know how business works. So anyways, how it's worked for me works just fine. People like options. So when you do a Frankie with me, you know, I've had someone that already had the voltage mod done and NEC tokens, but their 40 nanometer that was put on, I actually took that chip off and ran it through the x-ray machine, and when they popped the IHS off, as discussed, there was VRAM fractures, and guess what? They had green light of death. I swapped that chip out for them for the 265. They didn't need anything else. We just swapped the chip out. So that's why mine are modular. And why other Frankie builders care about how I do business is beyond me. I really don't care. Those people to me are nothing. I don't know them, don't care. I don't want to know them. I mean, I try to be part of communities, but I find it better just to stick to myself and do my own thing. I don't need nobody. I learned that a long time ago. Better off not needing other people. I got a couple people though that I work with, a guy at a data lab. I got another guy that's a super MacBook expert, you know, and I'm really good at phones and game consoles. And our little group, we share information amongst ourselves, and that's it. But I go on some of the message boards and try to guide or put my experiences or my ways of doing things. But it seems odd nowadays. Everybody just talks smack. Always got a problem. Always want to say something. Always got to prove they got the bigger D. You know what I'm saying? Anyways, we'll get off that subject. I was just talking about cutting corners. Yeah. So, here we are. Let me see if I can get this packaging open here. Ah, there we go. All right. Flip those over. And we'll get those put on. All right. Let's see. Okay. So we're going to put these on. So hot air these on. Hot air the whole thing. Get the SMDs all on there pretty good. Do 2 passes. Yikes. Tedious. I need a plant machine, but I can't justify it. I don't do a lot of PCB building. This is probably about it. I do mostly repair. So I can't justify a machine and an oven to automate this. I could definitely afford it, but I gotta ask myself why. I'll spend my money on something else, like a GPU for AI or something, or another 3D printer. Those actually make money 24/7 for me. Okay. Alright, got those set up for the most part. Get the hot air going. I'm gonna move you over here if I can. Let me see. Wow, but it's just got a warp in it right there. Let me see if back in. Put us somewhere where the phone won't fall. Maybe there. We'll see. I like to flow these twice. One to get the polys on there, kind of move them around a little bit. Get them lined up a tad. After that, flood them with some flux. Flux is always good. You want to watch out with this low melt stuff. These are still actually, everything's molten. Alright, we'll hit them again to get everything kind of snapped into place here. Little nudges just like you would with a BGA chip. Okay, we're going to let those cool down, and we're going to come over to these now. I don't know, I've seen people installing these. They appear to just solder them on. I don't know, that seems odd to me. They're not designed for that. They're actually designed to be basically wave soldered, if that's what you want to call it, on. I mean, these should be sat down, and I mean, we're not going to put them in an oven to flow them on because we can't fit that board in an oven, but we're going to flow these onto the board. So we're going to tin the board and the tantalizers with low melt. It's on this section right here, and this section right here. Just going to get them tinned up. They got to be perfect. We're gonna, bulk of the tin's gonna be on the board, if that makes sense. Okay. Do those, and I'm gonna set those over here, here, here. Now we're gonna flip these over. They already got flux all over the place, so not a big deal. I'm just gonna get them set up here. And I already tested the 1.4, but we can go ahead and test these other ones. They're hard to get a probe on sometimes. Come on. Ah, you little bastard. Let's see if I can get them to go. I got so much flux on them. Pain in my butt sometimes. There we go. Yep. Come on. Okay. The meter takes a while for it to respawn, so okay. That one's pretty high. That's good though, the more the merrier. But generally between 16 and 18 is where these land. Maybe, you know, 16 to 19. It varies. Depends how good the silicon lottery is, right? Okay, so we tested. I already tested my other ones that were built a way back, so these are ready to go on the board. And I'm gonna do that here in a little bit. We're gonna clean up and we'll get ready to put those on. We'll be back. All right, guys, we're going to now get the NECs, the board prepped here for the NECs. Okay, that's what we're gonna work on. So I'm just going to basically tin these up with some low melt and go from there. So put some flux down here. And we're going to use low melt because I'm trying to keep the board temperature down to a minimal. put the little voltage regulator on when we do these back NECs at the same time. Flip. Ready to do the next side here. Get it all prepped. Little humps going here. We're going to flow those NECs right on here. Or the tantalizers, should I say. It's ready. Now what we're going to do is we'll go back to the scope here, and I'm going to tack on the regulator here. This is what we're going to do. Get my tweezers. Where did they go? Yeah, whatever. I got another pair here we can use. Lots of pairs of tweezers here. Okay. Whoa. I just try to tack this down. Real quick. We'll get this on the scope though too, so and we're just tacking it down because when we flow the NECs, we're going to heat that up and it's going to go. Alright. So there's that. And actually, lost the tantalizer on the floor. Let me pause this and let me locate it. Alright, I found it. Ridiculous. Okay, let me see here. So on this section here first. Yeah, looks pretty good. And put a heat shield there. Alright. Move to the next two. That's that one I dropped on the floor apparently. So, gunk on it. Hair and gunk. Good enough. These will flow in for the most part, but you can try to get them lined up here a little bit before we go. Yikes. Yikes, 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 yikes. That's pretty good. Up to here. Okay. And protect the cell here. Okay. Alright. Our main focus, keeping an eye on this little guy here. And we'll flow these on. I need to get my little spectacles out. And the overhead light up a bit. though we should be good. I just like going ahead and doing that just because. Make sure everything looks flat, looks good to me. Okay. These heat shields flip over like the side. And I'll repeat the process. I might spend a little time on this more than other people, no clue. I try to get these to line up halfway decent. I mean, they will float on, but still. Okay, there we go. Let's get the hot air one going. Start at the cell and work my way back to the RSX that way. By the time I get to the RSX, it'll be a little warmer over there, less problems. Uh-oh. See a little piece of NEC debris there. Okay, I got it. Alrighty. Now, thing as before. That one looks pretty good. It looks pretty good, but we'll go ahead and do our thing. Top is pretty dang good up there, so I'm not even going to touch it. His eyes are filled in. Okay. Alright, so now we're going to let this cool and do some cleaning. And you ready? We could either test fire or do a delid on the cell. I'll think about it. We're going to do some probing too, check some values on the board now since we've done some work. Alright, we'll be back here in a bit. I'm going to end this and stitch it into the main video. Alright, so back. I checked the V-cores for any shorts. We don't have any. Resistance is about exactly where we were beforehand. 2.7 on the GPU. And actually around 3-ish on the cell. So it's pretty good. No shorts. So now what I'm going to do is, this person didn't want to do an ultrasonic, which is fine with me. I mean, ultrasonic's great, but it also comes with its own risks. So, I mean, really, unless I only ultrasonic things if there's water damage, because we clean all this up anyways. I mean, I'm gonna get some of the factory flux off here in certain areas and just kind of go around here and with some MEK, which, I mean, I got good ultrasonic cleaner, but this stuff, it's pretty, this MEK is it's pretty strong, guys. So I don't suggest you use it without a respirator like me, but I've been doing this for 30 years and I smoke and I've been exposed to asbestos, and so I got decent ventilation, so I'm not like panicked about it. I don't have an open container of it. As you can see, I have this in medical dispenser bottles, or whatever you may want to call them. I guess lab dispenser bottles is what they are. And so I'm just going over getting factory flux off the board. Just kind of going over the board, really. And we'll clean up the corner here last, because this gentleman wants to change the power supply out, so we're going to do the APS 231 and undervolt cell in RSX, so we get a good result. Which I would suggest just undervolting anyways. I've got a pretty safe undervolt that's pretty universal across the boards. Of course, we test play for quite some time and make sure nothing's goofy. Okay, that side's pretty good. And so we'll move up here. Got a little bit of areas up here that need some help. around the RSX that we did and the tantalizers. And this brush is getting a little bit nasty, so go ahead and switch brushes. Keep moving here. Go ahead, get the top of the MOSFETs and the coils. RAM bricks, NANDs, Marvel, all that stuff. First we'll clean up these IHSs a little bit later. Right now, we're not to that point. Right now, we're at, I'm pretty happy with what we got going on is where we're at, and just cleaning up a little bit. Gonna test our volt mod and stuff here in a second. Even with a wonky volt mod, the console can still start up. So, I mean, in all reality, we want to test our little test point right here above where we did the work and make sure it should be about 0.95 precisely. So that's a good idea. Plus, I like to record the V cores on both of these before I undervolt. So the next step basically is we'll see if we get some picture out of this thing. That's where we're at pretty much. Here's my little test clam. And usually the thermal paste is enough on there for what we're going to do, but we'll go ahead and put some cheap stuff on there real quick. Just a hair of the cheapo, the little test stuff that I use. And we're not going to worry about spreading it much or any of the jazz. We'll do the real deal when we get to that point. I'll show you what I do. For right now, we're just running some tests here. And see if this thing will turn on. I mean, it turned on for us once, but we've done a lot to it since. But everything's been done right. So in theory, it should come on for us, right? So I'm gonna move us for a second. I'll be back to grab you guys in a minute. Make some room over here. Stick you over here. Okay. As far as I remember, we did the syscon training, we did a test fire. With bring up, there was no power sequence failure, which means no shorts. Everything was detected. But there is still a possibility. I know the gentleman that gave me this, he knows this isn't a low firmware, so we shouldn't be in a GLOD situation that I know of. But you know, other things can cause problems too. So we're gonna see if we actually get some video here, because we haven't done that. We did a lot of work without doing that, but I've been doing this a while, so generally, I mean, it needs done anyways. If there's a problem after the fact, then you know, you usually don't want that. Ideally, if you got to replace the RSX again because of whatever reason, after you put these tantalizers on, how I do them anyways, they like to just fall off the board. So you got to remove them or protect them on the rework machine. So that's hit and miss. Okay, so we got that. Let me locate his drive. He's got a drive right here. Oh, come on. Oh, we should probably plug in the little fan, huh? Let's go ahead, we'll do that. Get some power here, power button. That hooked up. Okay. And we got this. Turn that off. Hook this up. Got a controller somewhere. We'll grab it. And I had a cord for it somewhere too. If I can find it, let me see it. Excuse me. Okay. Okie dokie, we got that. Alright, let's see where we're at. We get a standby light, that's good. I'm just gonna try to do the video reset. We'll see what happens. Got a hard drive light blink, that's usually a good sign. Green light of death usually follows a blink or two of the hard drive, a black screen, but I just seen the hard drive move quite a bit, so we should hopefully get a picture. We'll see. And we do. So we can go ahead and do that. Click that. And I should probably just get a Pro Go and wear it on my head for y'all, huh? Okay, yeah, I'm not real sure where this drive came from, what the story behind the console is, but we're up and going. So now what I like to do is we need to check a couple of things here since the system's on. Let me find my portable voltmeter. Alright, I found it. Let's see, I don't know if I can set this somewhere for you. Maybe. I don't know. Let's see, maybe right there. I'm gonna... Oh, got the fan nicking something on the bench. Okay, no biggie. So first thing we're gonna do is let's check our hardware volt mod here. And yeah, that sounds real good, don't it? Gosh, let me move that. Here, maybe I can... Here. You know what? you see it's on, so there you go. This is better. We can do it like this. There, I moved that so the fan ain't hitting something. Still hitting something, but whatever. That ain't my problem. We'll deal with it. Okay, so 9 point. Basically, it's where we need it to be. It's good enough. And then I like to jot down the V-core voltage of the cell. Okay, because we're going to undervolt this. So cell and RSX, okay? We're going to see what those volts are right now before we mess around. Okay. Man, what is under here hitting on the fan? It's driving me nuts. Piece of junk. Okay, whatever. Okay. So RSX is 0.982. Okay, we took note of that. 0.982. We're going to bring that sucker way down. We're going to bring that down to like 9, 0.9, 0.91, something like that. We'll see. Now, let's get the V-core. I'm on the V-core now. And that's 1.16. Not as high as some of them I've seen. I've seen them up to 1.2, 1.22, 1.16, but we're going to drag that sucker down probably to 1.08 or something like that. We'll try the 3D hex and see what it does to us. But that's why you want to make note of this, because this is how it was programmed in the Syscon at the factory. And this stuff's all different from the hardware level mod we did for the VDDIO. Okay, so 1.160 on that. Okay, so I've made notes of that. And I know we ain't playing a game or anything, but this fan hasn't left notch 1. It's running pretty cool. We are going to delid the cell, but once again, the RSX, there's no requirement for that. I've found, especially after you undervolt. I mean, it's just a risk. I mean, it's not a risk. It's 100% a fact that when you pry that off, yeah, I've got a chemical way. I've told you. There's a way to remove it without even putting anything on it. The IHS just falls off. But the chemicals are extremely toxic, extremely expensive, and extremely dangerous. So it's a last resort, and that's that. So we're gonna go ahead and get set up for the undervolt, and I'm gonna stop this video. I'm running out of space on the phone again. I've noted, look at my Gitto notes here, cell and RSX voltages at the V-cores. We're going to tune these down to, we're going to be pretty conservative about it. Because, every game acts different. I mean, I've got some good games that we're going to test on the new settings. But if you go, if you get too low, there's a particular game that could maybe throw it off. So it's best to just be, in between. Don't get crazy. Stay a little conservative. Okay, we're back, and we're gonna delid the CPU, put phase change on the die. We're gonna do an APS 231 19 blade fan. So first thing I'm gonna do is I'm gonna put the phase change material in the refrigerator, let it get a little stiff, and we'll go from there. So I'm gonna pause you guys for a minute and go put this in the fridge, and then we'll start working on some of the other stuff. Okay, got those out. Of course, these aren't new whatsoever. We're gonna catalog our pieces in our paperwork. Okay, so APS 23 wood, IT blade fan. Now, for the APS 23 wood, don't get me wrong, usually, I mean, back in the day, we used to just slap them in fats that were getting too hot with the backwards compatibles, and I mean, I never see really a problem on a couple systems I did, but for the most part, they would just work. But nowadays, since we have the ability to undervolt, to put the APS 231 in the backwards compatible, I do require you to pay for the undervolt, which we're doing on this customer's console. We're also going to be putting a 256 SSD in this console. Right now, we're in the middle of, in the other room, we are doing a hardware clone of the 60 gig to the 256. That's included in the price of the SSD. Sometimes people get their drives mixed up, but we clone them anyways. We clone them, and then in Linux you have to expand them. Otherwise they'll be the same size. I mean, you could put a 1 terabyte in there and it's still going to only be 60 gigabytes. So we'll go over that when we get closer to doing that. Meanwhile, we're going to, I think what we'll do is just undervolt this, is what I think we'll do. So that's what we're gonna do. So I'm gonna hook up the headers again so we can change the syscon stuff, and I'll try to show you what I do. Alright, I got us set up again here, and if I've been doing undervolting for a while, like I say, I'm pretty, you know, don't get nuts with it unless someone really requests a real fine tuning. But for our basic undervolting, we're just going to stick within a table here. That's pretty conservative. Okay, so 3D is usually like real safe for the cell. Okay, but we look at, sometimes you know, 3D reacts different. Like we were at, what was it, 1.17 on the cell. So if we do 3D, we're probably going to end up somewhere way lower than what it's stating, which is fine. 3D is just pretty good setting on cell. Sometimes I'll take it down a little bit, down to, I've got, you know, like 1.06, 1.07, something like that. So anyways, let's go ahead. I've kind of determined what I want to do on this particular system. Okay. So to do what we need to do there, here's the cell, here's the RSX. So we want to write 3110 3D. We're going to start with that. Okay. And really pay attention to what you're doing here, because you write the wrong one and you close this window. you might be in trouble. Okay. So, and I mean, if you were curious, you could read first, just to be safe. But it should be nothing, right? Okay. Should be FF. So, see, now we're gonna write that 3D. Okay, right. 3310 3D. Okay. That's pretty safe. And then we'll go back and read it, and we'll see that it's set. Okay. Now got to fix the sub. You got to write 32FE. Okay, and that should be 6965. It looks like. My eyes go so bad anymore. 6965. Yeah, looks right. So write it, and then go ahead and run the sum again. And okay, so we look pretty good there. Now, what we could do is we'll bring it up and measure our V-core voltage, right? And see what that did to us. Because we were at 1.17. Okay. So I'll toggle in, bring up. Let's see where we end up at here. Get back on the V-core. Come on. Okay, 1.072. So I'm pretty happy with 3D. I'm going to leave it at 3D. That's what we're going to do. Okay, I'm happy with that. And then I'm going to go back over to my console and shut down. Okay. Now, I think what we're going to do is probably for the RSX, we'll do so we were at like 987 something, I can't remember exactly, but I think I'm gonna do 26 and we'll see where that takes us. Okay. So we could go. Okay, now so there's a different one we need to write. It's 3111. Okay, 3111. Okay, so 3111, and I'm going to do 26. Okay. And we'll hit enter. Okay. And now let's go back to the EPP sub. We're going to have to fix again, and we're going to have to write 32FE. 32FE, and that's 693E. 693E. Okay. Should be good. And then we could check that. Make sure it's right. Okay. Looks good. Now, let's check the RSX V-core. So we'll bring up console. And we're gonna get over here. And I'm going here, and we're at 907. So we shaved quite a bit off. I'm gonna leave it there. Sometimes I do a little higher, but we've only shaved off a little bit. It's not a major concern. I think we'll be okay there. We'll have to run some games, and if we're not happy or something crashes or it acts weird, then of course we would have to fix that, right? But right now we're booting up just fine. So there's a way to kind of tell if it's too low or not. Some artifacting in games, things like that happen. So I'm pretty good with the cell. 3D is really safe. The RSX we tried to bring down pretty low. We was at, I believe it was like 0.98. Now we're at like 0.90. So 0.08 volts, quite a bit, which is going to pull the watts down and also change the temps quite a bit, if that makes sense. So kind of like, you know, what I'm talking about, dude. The RSXs have 40C. So once again, I don't always see reasons to be getting nuts with removing IHSs off things that don't need them. If that makes sense. See what the cell's doing. The cell's up there, and I put crap thermal paste on here. We ain't playing a game, of course, but I mean, let's get real. We're gonna delid that cell and put that phase change on there next. And that cell is going to shoot up probably to 70, 75. Takes a couple cycles for that phase change to take place and solidify and get to where it actually is. But me personally, even if that RSX is running 60 or under, dude, these chips are designed to run at about 65. I mean, that's what they are. So, I mean, I see them generally around 52 to 56 when I'm done with everything. Especially the undervolt. The undervolt makes a tremendous difference. You just got to confirm things work right. So, as of now, we'll shut the console down. And that'll be that. Okay. Okay. My shutdown is acting stupid, probably because I'm stuck without a disk there. So, anyways, I'm pretty happy with what we got. So we're gonna move on. Power supply, fan, delid CPU, phase change material, new thermal compound on the IHSs, way better stuff than what I just slopped on there here. Hard drives cloning. I'll show you in Linux how to expand that drive and get it back in a console so the console can utilize that space. Alright, so we'll get back to this in a little bit. I'm going to pause you while I get his clam out and stuff, and we get ready to move this out of my test setup into the... Alright, I'll move this over here. Get his clam out. Clean this up a little bit. We blow all these off when the console comes. If you purchase a hand wash, polish, and buff, which I say is more worth than an ultrasonic any day, because you kind of see I try to clean the board pretty well as we go. But we take all this, like we would take this fan out, and this whole thing gets, I mean, it gets blown out when it gets here, but we wash these, all the case parts that are, take all the electronics out, wash everything that's non-electronic, and of course when we put it back together, or before we do, polish and buff the case for $100, which is, I mean, that's something you're gonna see that is worth it. Okay, we don't do any of that polish and stuff here to gain what people seem to think is a C or 2, which is irrelevant. That's what thermal paste is for. Thermal paste fills the voids. So it's as simple as that. Even old dried out thermal paste, if it's got good compound in it, metals, it transfers the heat. Don't matter. That's how things work. Sony used not very good thermal paste on the dies and the fats. The slims seem to be a little bit better from what I can tell. Or they're just newer, not as old. But I got plenty of things that have old thermal paste and they work just fine. You know, sometimes it's not always the case though, so it just depends. Right? Okay, we're gonna put the fan in there. But I mean, bottom line on whatever we do here, I mean, if the chips are running hot, even the 40 nanometer, I mean, we'll delid it if absolutely necessary. But I have not found that I need to delid one ever. I've delidded 2, I believe, on special request, and that's fine. Just you're gonna get a waiver about it. Especially if you make me do it the caveman way. If you want to pay about $120, I'll do it the chemical way for you, and that's the correct way about that, where you will retain a warranty on your RSX. Okay, so that's a simple fact. We don't delid them unless we need to. I mean, there's no point. Of course, that RSX wasn't doing much when we fired it up, but it was active. We'll see what it does when we get a little closer here. Okay, so there's that. It's ready. Yeah. Stick that over there, and I'm going to bring our other board over here that we're working on and get it out of this clam, the test clam, and we're going to delid the CPU, get ready to do the thermal phase change on it. Let me unplug the fan real fast. There we go. Right. And always remember to tighten and untighten a little bit at a time. Even when the IHSs are glued down, it's not as big of a problem. But like for example on the cell, if you just tighten one side after a delid, if you tighten one side all the way and then start tightening the other side, you can crack the corner of the die. I've actually seen it. So always do what CPU manufacturers have recommended for a very long time, which is tighten in counterclockwise a little bit, a little bit. Of course, there's only 2 on this, so counterclockwise don't matter. Right? Right. Okay. Clean this low end paste off of here. Gee, I swear, ran out of space on the phone. So anyways, back to this. We're cleaning this off here. Okay, just a quick clean. Let's see. Ready to delid this thing. Warm it up just a hair. I think you got to worry about on this one. I mean, the mechanical pressure is nothing. This is more of a don't nick the substrate. I'll crack the die. That's pretty much what this is. Always a risk when doing this, but I've done quite a few of them. I used to, back in the day, use an old school filler gauge for spark plugs. They had a real thin filler gauge that you could use. Okay. And I leave after that's cut. I just leave it. I don't. It helps the IHS sit back down on the die a lot better in my mind than cleaning it all up. So that way when you tighten it down, it has some cushion to recompress down and not overpressure that die. Because if you're not gonna permanently reattach it, that's my suggestion. Don't take it off. Just leave it and put it right back down. Okay. Okay, let me go get the phase change out of the fridge and we'll put it on that die. I'm gonna pause you. So this stuff, make sure you just got enough to overlap on the die. Doesn't got to be perfect. Stuff's a little finicky. There's some different processes to get it on there. Each their own. Every time we do this, there's a little bit to it. See, things like this happen, and then it's a waste. You could probably make it work, but we're gonna try to do a little bit better than that. You know what I'm saying? So, I'll get us a new piece. Come over here and work this off of here. I like to use some of my little iPhone tools. Some of my pry tools. They seem to work. They're real thin and help get into their one section. And it doesn't have to, even if you get a little tiny wave in it or any of that, it's not end of world stuff. Because this stuff will reapply itself. So, but if you haven't done this before, it can be, there's a little bit to it. So, not the easiest stuff to work with. And my eyes, are so bad anymore. Oh, to get old. It's fun stuff. Where are my spectacles? Oh, here they are. So there's two little films on each side. So it's a pain. One's pretty easy to get off. Other one's a pain in the butt. But generally, we get it started. There we go. Like I say, that's kind of extra that came off the die right there. This is good right here. This is fine. Okay. No problems. That stuff, when it hits, like, I think it's 45 or 50 C, it liquefies, or it starts going liquid. So after quite a few different, like, heat cycles and things, it conforms how it should. Okay. All right. I've been using it for a while. I haven't had no problems. But like I say, when you first use it, you think, wow, this stuff sucks. First one I ever did, console shot up. And they all do it. The cell will shoot up to like 70 degrees or 70 Celsius, and you're like, this isn't doing nothing. But after a couple of cycles, it never overheats. That's the first thing. And after a few cycles, it settles in. So I don't know. It's a newer thing. I don't know how new, but you know, could be hype. Maybe it is, maybe it ain't. Who knows, right? Okay. Now, so clean these up a little bit. You could probably use the hot air wand to activate it, but I wouldn't suggest it. I would just put it in the clamshell, let it do its thing, and just do the cycles. Really just leave it on for a little bit, shut it off, leave it on, shut it off. You know what I mean? Okay. Now, let's get the good goop out. Good goop. Let's get this covered up. Okay. That portion doesn't need to be perfect right there. I don't know, that's how I do mine. To each their own, right? Seems to work good for me. Your mileage may vary based upon what type of paste you use and all that good stuff. Okay. Those clamshells ready. A little bit further prep here. And this guy didn't pay for hand wash and polish, so I mean, clean up some stuff like that we see but it's not part of the deal. Could be. Some of these old thermal pads. Problems, right? You could do this one of two ways. Try to keep, when I do that TPM, I try to keep everything together so it doesn't quite move until it's been cycled a few times. Once it's cycled a few times, that stuff gets tight. So much past that, guys. We got to do the hard drive I was talking about. But we'll go ahead and oh, I forgot one thing here. This console, I don't know, somebody put a factory plug in it. We do the plugs too if you pay for them. All optional. These are all optional things based on, you know, I get some people that do the heck. They go balls to the wall. $1,200 Frankenstein, right? Okay? And other people don't have that type of money or can't justify that. I mean, me, I would never spend that type of money on something like this. Of course, I can just do this for myself. I would do one of these consoles for myself, and I would do it to the best of my ability. All the way. If I'm gonna do something, I do deluxe. You know, I want the premium. I want the best. You know, but some people just can't justify that, or just don't have that budget. You know. But a lot of people do now, right now, because this is, you know, this is a console. A lot of people are in their 40s, early 40s, late 40s, maybe late 30s when they had a PS3. I don't know. So, it just varies, right? So, adults are doing a lot of these right now. Kind of reconnect with their childhood. Not to mention, I mean, it's been somewhat pretty much confirmed that the PS6 is going to do 654. Then you need this guy to do 321, right? That's what we're talking about. Okay. Guy's CMOS battery was about 3 volts, so he didn't want to spend on that, which is understandable. That's something a normal person could replace, right? You know what I'm saying? And I need to do one thing here. Nothing super critical. What is it? I don't know. Okay. So just stick that on there. Really, it doesn't mean a lot because I know how my boards are, what they should look like. It's hard to, I mean, if you're going to spend that type of time, I'm not really seeing it, if that makes sense. I got a little power button here somewhere. Maybe. We're going to cycle this thing a few times. We gotta do that hard drive. That's one thing we do need to do. So, and got him his APS power supply as well. We need to do that. But for now, getting that cycled. Let's go work on the drive. I'm going to pause this and bring us over to the computer. Or I may just do a screen capture over there. We'll see. So, but we're pretty much done with the Frankie. I mean, we do need to put this on there. I do check his Blu-ray, put everything back together, and play some games, run the console for a while. Make sure things are working, you know, but, you know, past this, I mean, this video is already like, I don't know, it's 2, 3, 4 hours long, so, I mean, because I haven't speeded anything up, I haven't skipped anything. We've done some talks, some chit-chats, but, I mean, just this IHS part here, I mean, we've already spent, we're at 28 minutes right now. So let's go work on the hard drive and we'll confirm a few things. Alright, so I was talking to the customer and actually they did a couple of different options. They decided to opt out of the SSD and they're just going to stick with the fan upgrade and power supply and undervolt. So pretty much we're done here. I mean, the Blu-ray needs tested, which I usually do that once we get the console partially back in the shell, you know, start reconstructing it, and then we test the Blu-ray. For this video, since it's been such a long deal, we're not going to do any of that. We did the rework. We did the important stuff to get it up and going. We'll put his original drive back in here. And on the next SSD upgrade that's important to someone, you know, when there's data on the drive, settings, game saves, possibly custom firmware, stuff like that. I mean, you can clone hardware all day long, but it's always going to be the same size. You have to go through Linux with some special software tools, encryption, decryption stuff. You have to have the console's key ID that has to be dumped to decrypt that drive and run it, and then you can expand that drive out. So for now, he said there's nothing on this console that matters, and from what I can tell off this drive, there is nothing. So I mean, at this point, I mean, what's the point of going through that? But then he didn't like, you know, this gets a little pricey, so at this point he decided to just stick with the 60 gig drive. He's a disk type player anyways, not a big firmware guy doing any of that stuff. So it will consume a little bit more watts, but nothing dramatic. So let's go ahead and we'll do the final fire up of this system, and let's see what type of watts it's pulling. Do the video reset, even though we already have, but no biggie there. Okay. Get our controller going here. Go ahead and run that. Let's see here. $13 that's good. Shot pretty low there. Just run through its rigmarole here. And that fan is not even moving. I mean, it's on the lowest notch there is. I mean, I don't know, you can't even hear it, so so as you can see, I mean, of course, I'll get this put back together partially, hook up the Blu-ray drive, and we'll work through testing PS1, 2, and 3, but that's for another video. This was hardware level, and like I said, if I get one of those in the future, which I generally do, every once in a while they don't care about the data, but if I do get one of those, I will definitely, you know, I'm not going to explain how I set up my subsystem and built, you know, customized kernels for cryptography and things of that nature to be able to take the key ID and basically decrypt the drive so you can access the information on it, and therefore allowing you to expand the drive to its max potential. That's another ball game, another video, and I may do it, I may not, but it's doable, just so you know. And that's the end of these videos. Sorry for the crappy recording, the phone running out of space, shutting off when a text comes in or a phone call, lots of different things, but I think I got most of the content to prove my point here, and I don't know if it's really to prove my point, but I want to show you guys how I do things around here on my, you know, little neck of the woods, my bench, my humble shop that's now in my basement that, you know, in all reality rivals real repair shops, because this used to be a real repair shop in a commercial location. So I've held on to most of my stuff. I sold half of my Rework machines and some soldering stations and things like that, just because I don't have that volume of room over here. And I mean, we're missing like a couple of things over here, but for the most part, not really. I mean, we've got the ultrasonic cleaner, we've got 2 Rework machines. I've actually got 3. I've got an Achi that's fully upgraded, but I don't use it too often anymore. It's actually sitting in the corner collecting dust. And you know, anyways, it's been fun. I could have got this console done probably a lot quicker than fiddling with this video, but hey, it was fun. So we'll see you on the next video. I don't do a lot of videos, but I'm sure I'll do another one at some point in the future. Y'all be cool and be safe, And you can contact us on the PS3 Frankenstein.com if you're interested in this service, and we can build custom packages out that fit your budget. All right, have a good one. All right, let's get this thing together. Now, one thing the customer had told me is that he swapped the Blu-ray drive, of course with the logic board is what I'm told, so, but something was wrong with this Blu-ray drive, so I may have to do the Blu-ray service. And we're going to find out here in a minute after we get some of this stuff together here. Don't like running this outside of the shell a lot. The fact in my mind is it can cause warping once things get hot, you know what I'm saying? So it's best to get it back in, get the posts screwed down, and get it secured in its final setup there. And I'm pretty confident about our volt mod, so I'm just gonna put it together and play some games. Let's see what happens. I said I didn't go nuts. Some people take the cell down around 1. You know, it's fine if you're doing that yourself, because if you run into a problem, you can roll it back. This happens to be a local console. So I mean, in theory, if there was a problem, it could be rectified without shipping, so that's a plus. But when we do undervolts for mill-in, we try to be careful about that and do some very good testing, which right now our video so far, I wasn't going to put this on there, but I figured I would show some proof here of everything running. But it's at 6 hours and 5 minutes, so this will add probably another half hour, hour, 2 hours, depending if the Blu-ray is really broke. Not necessarily. I got a pretty quick way to address the Blu-ray. So we'll see what's going on here. Let's just get the stuff in here. And we'll fire it up and see if the Blu-ray does anything at all, responds, or what's up with it. It could be a whole nother ball game. That. It's missing the drive screw. Up. Let's see what this drive's doing real fast. I'm gonna hope it just works. But if not, we'll make it work. Let's see what we got here. Let's try PS1 real fast. Let's see. Okay. Make that one there. Now let's see what happens. Oh, it reads PS1. Make our tests here kind of quick. Let's see. Put the old. See what we can. Put the old hit and run. Let's try that, guy. Depending, maybe his PS3, I don't know, maybe he wasn't a big PS2, PS1 person, and I mean, there's PS2. PS2 reads. And he had said he pulled this out of his other unit, or he pulled the one out of this unit when it died, and took the drive and put the other unit's drive in here. Who knows? Maybe he just happened to not get the ribbon cable quite plugged in right. I mean, I've seen weird things like that. Alright, let's try the 3. See if it works. Blu-ray 3. Well, appears to work. Unless you know how sometimes it can go. I was going to try to see if I could tilt you up to the screen there, but it don't look like it. Maybe. Maybe there. Keep an eye out for anything weird. I'm gonna test this a lot further, but I don't want to. I just want to show you guys. We'll look in a couple of places here in the house here, and we'll see. I know if there's a problem or not. Especially with clocking under voltage, should I say. We didn't do nothing to the clocks. We just reduced the power, which means same clock, less power. That's where problems can occur. We'll see how this laser's acting. It seems to be okay. I mean, we can do the Blu-ray for 125. If that includes replacing the tray and the lens, so be it. Gears, everything, the whole drive, whatever. The mileage is different for every unit. Sometimes it's a gear, sometimes it's a worm gear, sometimes it's a laser. Sometimes you just get things done fast, so just swap it out with a drive I've already got refurbished and rebuild the other one later. So every drive we do will be 100% functional if we touch it for that 125. Go ahead and skip this.
Hello?
Sarah, honey, I need to get your daddy on the phone.
Uncle Tommy, what time is it?
I need to talk to your dad now. There's something...
Uncle Tommy? Hello? What was that all about? Dad? Daddy? You in here?
Seem to be somehow connected to the
Where
nationwide
the heck
pandemic.
are you?
We've received reports that victims afflicted with the infection show signs
That's
of increased
nearby.
aggression, and there seems to be some commotion coming from the...
Who's that? Dad? Dad? What is going on? There's his phone. There you are.
Sarah, are you okay?
Yeah?
Does anyone come in here?
No, who would come in here?
Don't go near the doors. Just stand back there.
Dad, you're kind of freaking me out. What's going on?
Alright. I'm not going to tie up. We're already 18 minutes just doing this. But unit is working. We're not doing the hand wash polish buff on that, so we're not going to be showing that on this video. And 18 minutes here. We're going to be up to about 6 hours and 30 minutes for our main video, so we're going to call it. And I'll be back with a little information this is the end of the video, except for the little exit or extra or whatever you want to call it, whatever they call it. So we'll let this play this here a little bit later, or have one of the kids play it, and we'll see what happens.
Holy shit.